Yeah, all right. I should be sort of live now. Probably, maybe. Yeah, possibly. So I have to just pop out the chat and do a couple of things here. So it will be a moment. Hopefully, just a moment. Couple of things here. So we'll take a break from beating up on Professor Dave, and we'll, take some shots at T. Folse. I guess that's his name. Anyway, nuclear engineer, and he does. Very few of his videos are debunking videos, but he plays other people's videos. Basically, says "yep" a lot, and that's it. So, this is the original video that he's responding to was 14 minutes long, and he's made a video that's 21 minutes long. So he added a whole 6 minutes of conversation, reaction. And frankly, watching the first few minutes of it, it's all just absolute crap. He's saying yep to a bunch of crap that's not proven, and there's just no evidence, and it's pathetic, frankly, that none of these people have done any real thinking about what it is they're defending, and that's sad and tragic and horrible, frankly. So yeah, I think I can go ahead and begin. Don't think there's anything stopping me. Okay, yeah, so that's enough of a background, I think. So you'll get the picture pretty quick. He just doesn't do much.
Charming from up top down to the bottom.
He laughs a lot. It's all funny. And the jokes, the physics jokes are so funny.
Wow. Today we're going to be looking at a channel called Wacky Science, and specifically all of physics explained in 14 minutes. That's ambitious.
Yeah, but you know what? It's really, you're just saying, okay, can you break it down into simple mechanisms? So he really just does exactly what I've been talking about, right? So he does kinetic energy. Okay, just pretend, Then he does the fake gravity story, and there was something. Oh yeah, charge. He brings up charge, but their physics doesn't have any real explanation for any of it. I mean, it's all just they say so, with no evidence.
Those of you who don't know me, I'm Tyler Folse. I'm a nuclear engineer.
False.
A little over 10 years of experience in the commercial nuclear power industry.
Scary. And you think it takes 25 times the fuel to spin a motor 5 times as fast. I mean, that's what the formula says. You have to put the energy in if you're getting something that has energy out. So if kinetic energy comes out, you have to put the kinetic energy in. So you can't have it any other way. So you really do believe that something going 5 times as fast has 25 times the energy. And you believe it takes 25 times the energy to make it go 5 times faster. You believe that. I wish they would answer these questions, right? I mean, do you believe in the law of the lever? Have you heard of that? Where Archimedes says, give me a lever and a place to stand and I'll move the world. Do you understand the concept that for thousands of years people assume that levers conserve momentum, and the kinetic energy theorists say, no, they don't. Oh, shit. Wish you would have played that video.
From engineering operations to emergency response. I don't claim to know everything there is nuclear, but I can certainly share some knowledge. Let's see.
Hi, you're on a rock, floating in space, surrounded by more rocks, and gas, and a bunch of nothing, mainly. Oh, hey.
Right, there, so that part's correct. Okay, but obviously the small universe, the one that we're made out of, is the same circumstance, right? There's a bunch of rocks, little tiny bits of crap, and in some sense, you have to explain how they get moved around. And the trick is, the same stuff that's moving the big stuff has to move the little stuff first. And so the small universe is the only really interesting one, And it's the one where all the laws exist.
Hey, look at that. The rocks are going around the gas.
This kind of reminds me of Bill Wirtz.
I don't even know who Bill Wirtz is, but whatever. Yes, it's fun physics. Science should be fun. So yeah, the original video got like 7 million views. This guy redoing the video, probably one of his most popular videos, by numbers.
Hold on. What the heck is going on here? To understand, let's look at a little
Gravity,
bit of
orbital
physics.
mechanics.
Wait, did I say a little bit?
Quantum mechanics, you just said.
Worth knowing.
To find out what kind of magic this is, we'll have to go back in time.
So, right, Newton is where the last scientist existed, and then it just became woo. So after Newton, it's woo all the way down. All right, no good science, no good physics done. I mean, every time they have a choice between a reasonable answer and an unreasonable wooey pile of shit answer, they choose the wooey pile of shit answer.
Okay, not that far. Stop. Yeah, that's perfect. This is Gravity Guy, but most people call him Isaac Newton.
So that's funny to him. That's a good joke. Gravity Guy. Well, he's also Optics Guy. I mean, if you want to compare, well, it's really hard to compare, right? I mean, optics is so detailed, so much in there, but there's so much in the Principia also. But anyway, I mean, the gravity thing is a tiny part of the story, really. I mean, it's what he contributed to the gravity argument was just putting together the facts that Galileo already collected and probably should have said, hey, guess what? It's the same as an apple.
One important thing he said is that force equals mass times acceleration.
So he didn't say that. So, okay. So all the physicists just don't give a fuck that Newton didn't say that. He said force equals the change in your momentum. That's what he actually said. All right, and the change in your momentum is going to be the change in your velocity, obviously, but we're not talking about the force changing your mass. So you're just going to change your velocity.
Now, what do all these words even mean? Force is a push or pull.
Those aren't even words. All right, so there's no pull. So again, why do they keep talking as if there's an elemental pull? There's no elemental pull. Elementally, things collide. That happens elementally. Things don't pull elementally. And it can simply be argued that any time you see something that looks like a push or an attraction, it's the absence of a push that created that circumstance. It's not a pull. It's a missing push. I mean, it's amazing that they would contend that's not the truth. That they should be talking about gravity pulling us down, and they shouldn't be talking about it somehow pushing us down, which is so much more logical.
Something in a certain direction.
Sure.
Mass tells you how much of something there
Sure. All right.
is, and it's also a measure of inertia, but we'll get...
So there's whatever that is. I don't even know what that was an image of, but a measure of inertia. What is inertia? There's no such thing as inertia. So again, another fake concept that somehow things are sitting there saying, I don't want to move. No, they're waiting for you to push them. Is there some case where you can actually demonstrate that something doesn't want to get pushed? And that when you push it, you have to push it hard enough? It's like saying a piece of bread doesn't want to have mustard smeared on it. Well, obviously, if you're going to cover the whole piece of bread, you got to have enough mustard. If you don't have enough mustard, no, it's not going to happen.
Get to that later. And
It's amazing how much of physics just starts with F equals ma.
It's amazing how none of it that's rational starts with that. Everything rational about physics starts with Descartes recognizing that the energy never stops, that it just moves from object to object to object. And so all you do is take it in some big object and you end up displacing it all over. Diffracting it, scattering it, dispersing it into tons and tons of other things moving. I mean, it's just so obvious. The guy who did the silly denting clay experiments also did smashing clay into clay. And the obvious conclusion was, well, yeah, the clay moved, and that's where the energy went, into the movement of the clay, and the clay got hot. And that's where the energy went. It created heat. The momentum of the objects creates heat. It gets dispersed as little tiny things that then eventually go back into the physical universe as radiation. This guy ought to know what radiation is, you know, especially in the photonic sense of the fact that all heat ends up as the most obscure and entropinetic, okay, form of energy is photons. I mean, you could give examples. I mean, you know, I was going to do this in the next video, but like a bomb, you know, it's compressed to make sure all the stuff doesn't fly away. Like the first part of the bomb doesn't, like if I light some gunpowder, it'll tend to shoot all the other gunpowder away. So you wrap it so it can't do that. And then second, what you want to do is have the whole frickin' explosion happen as quickly as possible. That's another reason for the confinement. But then when you put the metal around it, what are you doing? You're taking energy that would be dispersed like a light bulb in a million little photons, and you're converting it into clumps, you know, big clumps of stuff moving. And so you have made it less dispersed, less spread out. So you're basically just saying you're converting the heat into something that's going to be moving, but it's going to take up much less space while it moves. It's going to move as a single clump instead of R squaring all over the place. You know, if it's just radiation, it goes like this. If it's a clump, it goes like that. Yeah. But, you know, the funny part is that the bomb with the clump, that is the bomb with a bunch of metal flying around, that bomb technically has less energy because it converted from a bunch of little tiny things going really, really fast into a few chunks going much slower. Oh, I mean, that's real physics. The shit they're talking is just religion. It's just garbage. They believe it because somebody told them to believe it, not because they saw any evidence of it. Again, where is there any evidence that it ever, on planet Earth, took 25 times the fuel to move something 5 times as fast? Where's the evidence of that?
The industrial-grade products you need. Granger, for the ones who get it done.
And I have
When
to
Verizon gives you a free phone on any plan, you use it.
I have to open the other window to get rid of the goddamn ads. Yeah, unfortunately, I was going to download the video, so I did think of being courteous for your sake. But the software I usually use for downloading doesn't work.
AI a lot.
Gemini, show me the concealer.
The long, thin tube in the middle.
But hey, it's the new Google Pixel 10 Pro, plus Google AI Pro for 6 months.
Boyfriend of the year.
What an annoying fuck to put these fucking...
Acceleration
forced
is the derivative of
immersion
velocity
videos.
with respect to time, but that's too many big words for my taste, so let's just say it's how fast your velocity is changing.
All right, right. So that's all that's happening. Your velocity's changing. So why did you say F equals ma? When all that's changing is your velocity. That the acceleration is just adding velocity or subtracting velocity. Acceleration isn't something special. It isn't something different. It's exactly the same goddamn thing. And just as you know not to square your 60-mile-an-hour number when you're going 60 miles an hour down the road, you don't say I'm going 60 miles an hour squared. You know, that would be stupid. All right, play.
The key takeaway is that if you apply a force to a
Yeah. So that's his contribution. Yeah.
fixed mass, you get a
That's all really what a derivative is. It's just the
It doesn't matter whether it's a derivative. Doesn't matter what it is. The point is that a isn't going to stay an a. You're going to turn it into an a squared. All right, that's the problem.
slope of a line, and an integral is the area under that line. There you go. That's all in calculus, sort of.
multiple amount of
Yeah, unfortunately, a velocity is not a volume. Okay, it's a linear amount, not a volume.
acceleration. If you know all the forces acting on a basketball midair, you can predict with 100%
Right. So that's, and what did he draw? A bunch of vectors. You know, a bunch of straight lines going in a direction, and there was no indication of something called a scalar somewhere. So the basketball is going to be flying, and it's not going to have any scalar energy. It's going to have, you know, real vectors of motion.
uncertainty if the ball will go in the hoop or your neighbor's windshield.
So that's worth a chortle too. See, I just don't have any, I guess I have no sense of humor because I find that little silly, turdy stuff like, oh yeah, that's just so funny. Oh, look at that fail video. No, doesn't really work for me.
Whoa, did an apple just fall on my head? Yes, Newton, it did. Yeah, that must have happened for a reason, said Newton, as he discovered that two masses attract one another, making the apple fall.
So attract one another. So through what mechanism? Oh, that's right, no mechanism. The magical space creates free energy. That's their theory. So this nuclear engineer believes that space generates free motion, that is free momentum. Things start moving, and there's no force that did it, and there's no force you're going to put back. So you're going to use something that gave you energy, and you're not going to give it back in any way. So how the hell do you have an entry problem in the universe? How could the universe be getting colder if there's a huge supply of free motion? And that's what they believe. It's free motion. It's absolutely free. Okay, nothing creates it. You don't have to give it motion. One object moving doesn't have to hit it and push it. There's no mechanism from which it came from. So it completely breaks the Descartesian notion of conservation. And the only way you fix that is to recognize, well, why is the Earth core 4,000 degrees? Well, that's right, because the Earth has absorbed a bunch of momentum, converted it into heat. And now that's why we fall in gravity, is because there's a differential. There's more energy coming from the raw universe above me than is being at equilibrium emitted from the Earth at this one moment. It's a little behind. The energy that should be pushing me up and keeping me from hitting the Earth, that energy is making heat inside the Earth instead of getting to me. It's been slowed down by having to go through the Earth. Now that perfectly rational explanation is just that, perfectly rational. And yes, there's this drag issue, but I've already explained how there's no drag. Moving into a force that's moving towards you, there's no way you can move into that force and create more energy, because the energy you're evading is going to catch up. So you can never make more energy on one side of you than the other side of you by moving into it. Moving into it will not make it more force. It just means you got to it earlier, but it's going to catch up, so to speak. The balancing force will show up. You just have to wait for it.
Yes, even you, no matter how ugly you think you are,
Wow.
attract pretty much the whole universe at least a little bit. Hey, can you put that on paper?
So that's more just baby talk, blah, 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 blah. Obviously, it's all electrons and protons. The only real universe is the electrons and protons being pushed around by a force. The atoms are a slave to them. Then the molecules are a slave to the electrons and protons. The compounds are a slave to the electrons and protons. And ultimately, we're a slave to them. Nothing I'm doing is me doing something. Electrons and protons had to do it way before I did. Yeah, in cosmic terms.
It's true. You do exert gravity, but you're not very big compared to a planet or anything, so it's insignificant compared to friction, for instance.
Okay, but it's significant enough, whatever these forces are, you could argue, okay, that they're the elemental force is charge, and charge is obviously very strong because it's keeping all of your atoms stuck to each other.
Said Newton, who gave us the law of universal gravitation. In other words, how much do bodies pull on each other given their mass and distance times a...
So I would argue that that's not really a correct formula because there's no reason to multiply the masses. Gravity is an individual function. The Earth makes the moon move, and the moon makes the Earth move, and the two are completely independent of each other, and the movement is just additive. Whatever the moon moves plus whatever the Earth moves is the total force, and that formula won't give you that number. So it really should be G times M1 over R squared and G times M2 plus G times M2 over R squared. But whatever, minor point.
constant. Bigger mass, bigger pull. Bigger distance,
So why? Why do they just always do this? Why do they know it's a pull? Why do they know it's not a push? Well, I guess the obvious answer is because push implies that something is doing the pushing, and they don't want to deal with the fact that they don't have a something. But that's the only reason. There's no reason to actually think it's a pull. And especially if you think about it elementally. What would be an elemental pull? I mean, it's just an impossible thing to think about in terms of, what, magic? You know, outside of magic, how do you elementally create whatever this pull thing is? And as I just pointed out, obviously the answer is, well, you just eliminate a push and there's no balance anymore. So if I want to move me that way, all I do is take some of the push out of that way and I'll go that way.
smaller pull. Actually, a lot smaller pull. You see, as the distance increases, the force gets smaller by the square. That, my friends, is the inverse square law.
Right, and it's what a photon is doing. It's what the candle is doing. So it's not like this was a mysterious function, right? I mean, the inverse square law just has to do with anything that spreads. You could even say a lighthouse or anything. And it doesn't even have to be spherical to get the idea. All it has to do is create a cone, and you can argue inside of that cone is the inverse square law. The bits are separating in 2 dimensions. They're getting further apart this way, and they're getting further apart this way. So that's the inverse square law. It makes a square. Shit.
Gravity is also the reason why planets in our...
More reason to just recognize it's just like photons coming out of a light bulb. It's just in reverse. Gravity is just the opposite event.
solar system or...
Same is true for calculating how much dose you get from a nuclear source. So if you...
Right, because it's particles flying out of a point source, which is spherical. And so, yeah, they're spreading in 2 dimensions. Duh!
You double your distance.
And frankly, there's points. You got to also raise the point that a lot of these, it's even worse than the inverse square law, because you could argue that the particles don't travel very far. So, I mean, the electrons and the protons especially don't go very far. So they're not very penetrating. So not only, I think it'd be wrong to imply that short of being in a vacuum or something, you're going to have a hard time making the argument that it's an inverse square all the way to infinity. It's not even close. So it's even worse than the inverse square law, because frankly, every inch the little bits of crap have to travel, short of the gamma radiation, they're not going to move. They're going to stop. They're going to be, the paint spray is going to get caught in the atmosphere, so to speak. It's not going to be able to get through the atmosphere. So, nuclear engineer, and he thinks radiation travels an infinite distance. He should know better.
From the source, your dose is going to go down by a factor of 4.
It's going to go up as you go closer by a larger than a factor of 4, because a ton of those little radioactive bits hit atoms in the atmosphere and were absorbed. So they're not going to hit you, because they already hit something else.
That's why you look at distance, also time, and shielding when you protect yourself from radiation.
Right, shielding, that would be atmosphere. So again, it's not really the inverse square law. It really technically isn't, okay? It can't happen because the particles don't have a perpetual motion. They run out of velocity.
The sun. They got their initial velocity when the solar system formed out of spinning gas, and since there's nothing...
Okay, it says you spinning gas, okay, so who knows what it was? Chunks of crap, obviously. Something blew up, and then it all contracted again, and basically, and, I don't think there's much else to the story. The heavier stuff didn't go as far, so it got collected first, and then the lighter and lighter stuff got collected later.
Nothing in space to stop them from moving, they'll keep moving. Hey, that's Newton's first law.
Right, and it's not been proven, but obviously that's the principle, and it just depends on how much crap is in the way. So you could argue that there are some atoms in space Not too many, but there are there. And obviously your motion will be absorbed by those atoms eventually. They will be friction. But it takes a lot of them, and it takes a long time. But it's just a fact, okay? We probably can't throw a wrench to Alpha Centauri. It'll probably hit enough little pieces of dust and shit to absorb the substance of its motion. Maybe. I don't know how many. Let's just say you can't throw one across the galaxy, okay? It's not going to make it, because it's going to hit other matter and give its momentum away.
The sun is so massive that the force of gravity keeps pulling the planets towards the sun. But
right, and the sun is so massive, but the surface gravity is only 80 times that of Earth. But it is gigantic, and that's why it's on fire. It's because it's absorbing a lot of motion from gravity. It's got a bunch of mass moving towards its center, constantly pushing on it. Every single piece of matter is pushing, creating pressure and heat.
the planets are fast enough to...
It's just amazing. Okay, this guy's a nuclear engineer. I wonder if he actually believes there's uranium in the core of the Earth that somehow has been burning for 2 billion years. Does he believe that?
To essentially fall towards the sun but miss it, and this goes on forever.
Right, and so this is a perfect example of the fact that it's a time-dependent force. The faster that thing goes, the more it doesn't get bent, and the slower it goes, the more it does get bent. So it either crashes into the Earth or it flies back out. And that's the truth, right? If you want to put something in orbit, you can't just shoot it towards the sun. If I just shoot it towards the sun, I'm either leaving or I'm crashing into the sun. To stay in an orbit, it has to hit something that slows it down. If it doesn't slow down, it can't stay in an orbit. I mean, a fun fact that nobody teaches. But it's a fact. You can't shoot something into orbits without something interfering. If something doesn't provide a means of reducing your velocity, you are doomed to leave or doomed to crash.
Getting around orbit.
Another word for orbit is a clever way to fall without hitting the ground.
I mean, when they went to the moon, they couldn't just shoot at the moon and go into an orbit. They had to slow their speed down to get into the orbit. There's no other way to get into the orbit.
Because in this case, the ground is the sun.
That's kind of a lie. Most orbits are not perfectly round, but more...
Okay, and this is not what they are. So this is another bullshit drawing, because they're not that eccentric. So yes, they're not perfect circles, but we're talking about 4 to 8 degrees of off, not 30 degrees. This drawing is like 30 degrees, 40 degrees. It's not that eccentric. We're talking about an 8% difference between the distances. That's fucking 30 or 40%.
Egg-shaped, and Pluto's orbit is just a complete mess, but you get the idea. In this case, the gravity is what we call a centripetal force. One thing many people could...
You call, yes, we call, that's you play your little games that it's some kind of force when there's no such thing. You first don't even understand that gravity is a force, and then they talk about some centrifugal force. There's no, obviously that force can't exist if gravity doesn't even exist as a force. So it's all just such bullshit.
Confuse is mass and weight, and no, they're not the same.
All right, yes, but they're the same in the sense that we're using the word weight, and we're saying this is our standard for weight. We're going to talk about how much a pound is based on Earth's gravity. And that's the standard. We're just using Earth units. But it's perfectly valid to calculate mass as a weight.
Mass tells you how much of this blob there is, and weight is the force of gravity the blob would feel.
Yeah, and it doesn't matter which one you use. You're always just going to give it momentum. So gravity gives the object momentum. It takes a mass and gives it a velocity. So, duh. That's the weight. The weight is momentum. I mean, I don't want to have to say this again, but you turn a scale on its side and you start pushing things into the scale, you can duplicate the exact momentum created by gravity. there's a speed, 1 mile an hour, I would argue, pretty close to it, that you push an elephant into the scale at 1 mile an hour, and its impulse energy will read elephant weight, 2,000 pounds, whatever. Put a mouse in, same speed, 1 mile an hour, and it will read mouse weight, 15 ounces, whatever. Yeah, this is so bad.
To make things clear, your mass would be the same on the Earth and on the Moon, but the weight you would perceive is different because...
So I'm just saying, it's just silly to talk about mass without talking about what it takes to move an element of mass. So you have to define a gram or a kilogram or a pound or some kind of unit of mass and have something to connect it to. Without units, the number wouldn't have any coherency.
The Moon has a weaker gravitational pull, meaning a weaker force acting on your mass. So, really...
You very seldom see a personal scale measured in newtons, and you're very rare...
Right, well, so, yeah, but that's what physicists often do, so you will see it. But, yeah, why don't you just forget about newtons, because you can convert newtons into joules, so why don't we all just use the one standard? But they won't do that. They're still going to talk about horsepower and calories and Kelvin and all kinds of different ways of measuring the same exact thing. Watts. I mean, it's all the same thing. You can't evade it. And really all it is pressure. It's just weight. It's just momentum. It's all momentum, force, weight, heat, pressure, blah, 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 blah. Momentum. It's all momentum. It's just masses, moving velocities, period. There's nothing else that happens in the universe.
Really work in newtons in a nuclear power plant, even though there's all kinds of forces. But then again, I've mainly worked at plants in the U.S., so we don't use the metric system as much.
Oh.
Yeah, so what do you use? Foot pounds? But whatever, doesn't matter. Oh, another annoying commercial. Fuck. There's a ton of these.
This your bag, sir?
What gave it away?
Oh, you the Geico Gecko! I filed a claim for my car with the Geico app. Only took 2 minutes.
Well, I mean, Geico's all about getting more than just savings.
The next time, how about less fluid ounces?
Fair enough. Oh.
Get more than just savings. Get more with Geico.
Yeah, it's even
Overweight, you're just on the wrong.
Okay. All right, well, let me just see if there's anything in the old chatteroni. Yeah, the old chatteroni. All right, a bunch of blah blah. So we'll see what the morons are saying. The participants. Let's see what the participants have to say. Hey, you got a ton of comments. LOL. I don't know what that means. It's for normies, idiot. I don't even know what that means. Okay, what's that life guy? Okay, do you see your argument as a replacement of current... Well, god damn, duh, fuckhead. I mean, 15,000 videos because I agree with the physics. It's just semantics. I want them to use my fun words instead of their silly words. Oh, man, you're just so dumb. As a refinement, what's the refinement? They have wave particle. I obviously have just particle. Okay, I mean, in every case, they have no force for gravity. I have a force, obviously. They have no force for charge. I have a force, obviously. Come on, it's just, a refinement that only applies to specific cases. I mean, just amazing. Sorry, you're amazingly stupid that you haven't figured out that, no, I think the whole thing is crap, that they haven't done anything smart since Isaac Newton died. That's it. That was the end of rational physics, and all was just mush after that. They believed things without any goddamn evidence, and that's the truth of it. They never dropped 4 pounds 1 foot and 1 pound 4 feet. They haven't done any fucking elemental, fundamental experiments. All right, well, anyway, there's a lot of papers proving this. That's a lie, so I'm just going to fuck you. You're not going to talk that shit here. So go ahead. I can email you 100. Go ahead. Please do that, motherfucker. Jesus fucking Christ. I mean, I can't believe I make all these videos saying, please, please show me some piece of fucking evidence. You're not going to show me 100 fucking pieces of evidence showing it takes 25 times to spin something 5 times as fast, you fucking idiot. You're not even going to come close to that, you fucking liar. Oh, God, these people are so gross. Gravity doesn't depend on time. It's 9.8 meters per second. 1 second. That's not time dependency? What the fuck? That's like saying paint spray isn't time dependent. It doesn't matter how long you stand in the spray. It just matters on how far you go. It's like saying streams aren't time dependent. It doesn't matter how long you're in the stream. That won't decide how far it pushes you. I mean, you're so goddamn stupid. God, gravity is constant. What does that have to do with anything, moron? Prove the formula using time. I've already done that. Okay, you're just going to get timed out. This is taught when you see rotating systems. Okay, that's just babble. Okay, orbits are calculated using KE energy. Where is that even true? Go ahead and show me that. Show me where somebody calculates an orbit using kinetic energy, shithead. Because we already know the thrust on the rocket doesn't move the spaceship, moron. We also know the thrust doesn't move a satellite either, moron. So how the fuck could the kinetic energy be part of the calculation, retard, when there's no connection between the actual kinetic energy you're using, fuel, and the fucking goddamn motion of the object? There is no kinetic energy. Kinetic energy doesn't move anything in space, you dumb fuck. Okay. Let's see. Eccentricity is not measured in degrees, doofus. Okay, well, that's another reason why you can just go fuck yourself. Yeah. You can fuck off. Waste my goddamn motherfucking time. Shit for brains. Alright. Look at all that crap he typed. I mean, Jesus Christ. Oh, I'm so special. I deserve to make 400 comments versus everybody else's. Because I'm so fucking special. God damn it. What a piece of shit. PSR he calls himself. Whatever that is. Piece shit. Yeah, piece shit. Rock. Yeah, piece shit rock. Alright, he's a shit rock. Okay. Gem of a stream, by the way. Whatever that is. I don't need that kind of crap conversation either. Anyway, moving on. So that was a waste of time. I interacted with humans. Oh, yeah, that's a... You want to waste time? That's what they... Go ahead. Have some interaction with a human. Fucking idiots.
Wrong planet. Alright, enough about Newton. Let's break some stuff. If you ever dropped your phone, it might look like this.
So this is where he says the words kinetic energy. So somehow it wasn't the momentum exchange that broke the phone. No, it was kinetic energy. The magical kinetic energy did it.
What the hell, Ground? Why'd you do that? The answer is energy. You know, the thing kids have after eating gummy bears. Energy has the unit joule, and it's not like force. It doesn't have a direction, it's just an...
It doesn't have a direction. Well, the fucking phone had a fucking direction, didn't it? I mean, how can they keep saying this shit? I mean, why do people believe this shit? Are you all this fucking stupid? They tell you there's a thing called a scalar. It means that a train running down tracks that can only be going in one fucking direction, that all of its MV is in one fucking direction, and somehow the energy is going in more than one direction. How the fuck can you believe that? I just can't even imagine how somebody can be that fucking stupid. So he says, joules do not have directions, moron. Prove it. Proves it. How the fuck does it prove anything? Where did you explain what the non-directionality of the train is? How is the energy non-directional? The M and the V are in a clear direction. How can the energy be in not that direction? God, amazing stupidity. No, scalar is the magnitude of the vector, absolute moron. Well, how are you explaining anything? How is that an explanation? Okay, that's not an explanation. So you're just another asswipe. You can fuck off too, fucker. God, these people are just so fucking stupid. I'll give you 24 hours. Fuck off, fucker. Ugh. Puke. What human garbage. Ugh. Shit. This planet needs a cleansing. And yeah, the humans need to be cold. No, I better not say that, especially in the current atmosphere. Nobody should be hurting anybody. Arguments should be allowed to take place. But the fact is none of these people will argue. Yeah, they'll just make declarations. They won't actually argue anything reasonably and logically. They won't answer any of the direct questions. But again, why do you people believe this scalar crap? I just don't understand how you could think the MV is essential to the MV squared. You do understand that the kinetic energy formula has MV in it. And we know that in every single case, the MV we're talking about is linear motion. We're talking about something moving in a vector, a straight line. How can the MV, the momentum, be a vector, and then the MV squared is somehow some other thing? How can it possibly be some other thing? You're just a waste of time. Oh, I'm actually crazy. You're actually small penised. Fuck you till you're dead. Oh God, these people are just such a waste of time. Oh, Jesus. Humans.
Number that's kind of chilling there as a property of a thing.
Yeah, otherwise known as a scalar.
Ah, there he says the magic words. A scalar. Scalar what? What the fuck is scalar energy? Draw me a picture of scalar energy, please. Please, somebody draw me a picture of scalar energy. What the fuck are you talking about? And then show me how it actually does any work. Ever. 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 Yeah, no, they're never going to show it.
There's two main kinds of energy, kinetic energy and potential energy. In plain English, energy of movement and stored energy due to some
That's right, stored energy, or there's energy like streams. The Mississippi River is energy. The boat sitting on the shore doesn't have any potential, doesn't have anything, it doesn't have anything. And it's not until you put it in the stream that it can acquire something. And that's the rule. You have to get your energy from something. You have to get motion from something. You can't just have motion. You have to get it from somewhere. The Earth is going in an orbit because it acquired motion, because things hit it and gave it motion. It wasn't some magical process. Ugh, assholes. Stop censoring people. I have no obligation to pay any goddamn attention to shitheads who are going to sit there, deranged loser. I don't have any obligation. Fuck you. You don't know me. You don't know shit, you fucking piece of crap. You have no fucking goddamn authority to come in my house and shit on the floor. If you can't behave reasonably and make a physics argument, then fuck you. You can just go to hell. Yeah, that's what you can do. And hell is timed out in this case.
Circumstance. For example, when you held your phone, it stored gravitational potential energy due to being held above the ground at a certain height.
Right, and so we know that doesn't mean anything. We know that the gravitational potential is exactly the same any height. It doesn't matter. You're talking about how long you're going to allow it to fall. You're talking about how many seconds you're going to allow it to fall. How much time are you going to allow it to fall? That's how it's going to decide how much energy you'll collect. How long is it going to be in the stream? How long is the boat going to be in the Mississippi River? That will decide how much energy the boat has. Nothing else will. The distance is irrelevant. The only thing that matters is how long was the stream pushing the fucking boat. How long were you standing in the paint spray? That will decide how much paint is on you. How can you people be so fucking stupid?
Once you dropped it, that potential energy was converted into kinetic energy.
And right, it would have been the same thing. I could have dropped it from 100 feet high and dropped it 10 feet. I could have dropped it from 50 feet high and dropped it 10 feet. I could have dropped it from the ground level 10 feet. And it'll all move at exactly the same speed. It'll hit with exactly the same force because it really doesn't make a difference. Gravity doesn't change enough over those short distances. So it's not about the distance in some space. It's about how long is it freely being allowed to collect the energy without any friction. And obviously the ground is hard friction. I could put a wall up and then drop the phone and have it bang into the wall. You know, little bumps, little bump, 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 bump. You know, put the wall on a little tiny slope, have the phone hit the wall. It'll acquire less velocity, quite obviously, because it's going to give away the gravitational potential energy. Fuck you, people are so stupid. How is there going to be no friction? Air friction, moron. So again, more waste my goddamn time. Where did I say there's no air friction? But we know in these falling cases, it doesn't add up to anything until you get up to really high speeds. You have to create an awful lot of air pressure for the air to interfere in your falling rate. So just say some more shit that has nothing to do with the subject. Air resistance for cannonballs, say. If I dropped cannonballs off the Leaning Tower of Pisa, there's not going to be any air resistance that's going to make any goddamn difference. Oh, you people are just so goddamn stupid. Yeah, of course, it makes no sense for me to ask you, have you ever seen it take 25 times the fuel to spin something 5 times as fast? It doesn't make any sense at all. You can't understand that simple question, huh, motherfucker? Too complicated for you, fucker? Alright, so Helen, you're done. Alright, I'm not going to do this every night with you, so you can just fuck off. Let's see. Oh, yeah, there it is. Fuck off. Yeah, you're done. I mean, look, this pointless trolling is of no value. You either answer my question, have you seen it take 25 times the fuel to move something 5 times as fast? Can you give me a piece of evidence? Can you link to a piece of evidence? If you can't do that, then just shut the fuck up. Because you have no evidence of your wacky theory. Oh, fuck this. Alright. You can just fuck off, fella. Not gonna bother. So just keep talking shit, fuckers. Yeah, go ahead. You can't play fair, right? You can't provide any evidence, right? You can't link to evidence and say, well, what about this experiment? You can't be a little bit polite. Nothing. It's just this, you're just going to talk this shit. So here's the only look. In an explosion, the fragments would travel in vectors, and even the heat could be tracked as vectors. Yeah, but you don't understand. What vector are they going to travel? You see what you can't figure out the argument that if I have a piece of heavy stuff here at the bottom of the the inverse square spreading, and I collect all the energy here, it means that one object will go up in space and there won't be any energy going in all of these places because I collected it all here. You get it? So now the energy is in tiny packages, so to speak, compared to being dispersed over a huge area. So it's the same thing as taking a light bulb and smashing all the light into a beam. You get it? Fuck. People.
As the phone fell. Then it smashed into the ground, and the phone absorbed some of the energy, making the screen go boom. Work.
So the ground and the phone share the contact, and they have to decide, well, based on what they're made out of, who's going to get what. Okay, so if it's the ground's made out of steel, then the phone's going to do all the braking. If the ground's made out of mud, then the mud's going to do all the displacing.
Is defined as force applied over distance. For example...
So again, and it's not true. It's mgt, not mgh. Distance isn't relevant. Time is the only thing that matters. Force, time. Pressure, time. Distance is bullshit.
If you lift an apple by 1 meter, you would have done about 1 joule of work. This happens.
So this is the other part that's just kind of funny. So the apple represents 100 grams. So let's just understand. And you're just saying that if you drop 100 grams, it's going to weigh a kilogram.
happen by converting chemical energy stored in your body to
You drop it a meter, it's going to weigh a kilogram. A joule.
gravitational potential energy stored in the apple. As you may
So again, all of this energy storage you have to understand is just being atoms that you're putting in some kind of condition where their electrons are more compressed and they can create velocities. Because stored pressure is the same as stored velocity. The electricity is an example. You compress a bunch of electrons, you've stored pressure, which means the atoms are essentially elastic, and you've compressed the springs, and now the springs can produce velocity. And the higher the voltage, the higher the pressure, the higher the capacity to create velocity.
Silliness aside, this is an excellent explanation thus far.
Energy.
So he just said this is excellent, and it's complete crap. The word momentum hasn't even been spoken, correct? Hasn't even been spoken. So the Newtonian concept, the Descartesian concept, the Galilean concept, completely lost here, this quantity of motion. Newton clearly said, right underneath the second law, right underneath their lie of F equals ma, which he didn't say, but right under that, the first sentence, he says, twice the force, twice the velocity. 3 times the force, 3 times the velocity. No indication of any kinetic energy bullshit. Yeah, Gilbert, I'm not sure I want to read your comments, frankly. So,
and work have the same unit, joule. So they must be the same thing? No, energy is the total amount of work that a thing could possibly do, and work is just the stuff that actually happened.
So we know none of that happened, so that's the big joke. So they're saying work is some sort of special action or motion that takes place, but work is heat. Sometimes the work you're doing is trying to create heat. I mean, when you're spinning a little stick and you're trying to make friction and create a fire, well, obviously the work you're doing is quite deliberate, and what you're doing is you're trying to turn things, big things moving into tiny things moving. Duh. Yeah. So this whole concept that work is some special thing, no, it isn't. Friction is work. All contact is work taking place. And the simple truth is in none of the contact is kinetic energy conserved.
And required energy.
Very well said. Energy being the capacity and work being the actual transfer.
Oh, doesn't make any sense. Energy being the capacity and work being the actual transfer. You can't possibly not transfer. You can't possibly not conserve. So again, Professor Lewin says nature can deal with kinetic energy one way or the other, but nature can't finagle momentum. Richard Feynman says energy is blocks, okay, solid little blocks, and you can never destroy them. So yes, you can hide them somewhere, but you can't destroy them. They're always there somewhere, okay? Maybe you can't see them, but they're there. And yet these assholes are sitting here saying there's this magical energy that you could just poof it in and out of existence anytime you feel like, and it can do work or not do work. It doesn't make any sense at all. All energy has to keep moving in the environment. It can never stop. It only transitions from object to object. And clearly we need energy to be in big giant clumps going in one direction to make any use of it. And the more dispersed it is, the less use we can make of it. Because we really can't just capture it in a bottle. You can't just put a funnel and say, give me some energy, and I'll put it in my bottle and drink it later.
A weight that's too heavy for you, you'd feel like that took a bunch of work, right?
It did take a bunch of work. So again, this is hilarious. They still haven't figured out that this is work. And I can make this easier. I can use less energy or more energy in lifting this object, because I could lift it over a whole day and keep collecting 9.8 meters per second of force every second all day long. Or I could just do that and collect a half a second worth of 9.8. I mean, it's just such a bullshit for them to say it's not work. So again, they think it's the same because the distance is the same. So it doesn't matter how fast I lift this, they say it's the same amount of energy. No matter how slowly I lift it or how fast I lift it, same energy. And we know it's not. We know that rockets get highly efficient the faster you can get them going because they get through the gravity quicker. The quicker you can get from point A to point B in gravity, the less the gravity will affect you. I mean, that's just so obviously true. I mean, here's a gravitational body. I'm going to fly by it. The faster I fly by it, the less I get bent. Because the gravity didn't have any time to push me. And the slower I go, I'm guaranteed to crash. Duh. And I have to argue this with adult humans? I have to argue this with a nuclear engineer? Hilarious. Fucking morons. Planet is just covered in moron.
Well, yes, but your feelings are invalid in the face of physics. Mathematically, no work.
Now all this little clickbaity, Simpsons didn't, they just got, I find that pretty annoying when people have to use all this other creative intellectual property to make their own property look like it's funny or entertaining or interesting. No work has been done. That's what he just said. So you're holding something up against gravity. The force is definitely going through you. Your muscles are always trying to fine-tune. And so it's a huge amount of friction as the energy goes from your hand into the ground. And that's not work.
Has been done because work is force applied over a distance, and since you didn't move
Retarded. Just absolutely retarded.
the weight at all, no distance
Look at him smiling. Like this is, oh yeah, that's really sensible physics. Yeah, that's so clever. No, it's really fucking dumb.
means no work.
Yes, you applied a force, but you multiplied by 0.
You multiplied by 0. So yeah, you applied a force and it just magically disappears into nowhere. Because it's magic. You don't, it doesn't have to go anywhere. It doesn't have to make heat. Doesn't have to do anything. No, it just disappears. I mean, you can know that this is all bullshit, right? Because you could take a Newton's cradle. You take 2 steel balls and have them hit each other. If they're allowed to bounce, there's very little heat. But if you push them into each other, make sure they can't bounce apart, you can burn a piece of paper. So, I mean, it's just showing you that the energy has to go somewhere. It can never stop moving. After it burns the paper, it goes into radiation that, goes back into the environment as photons. It never stops. And those photons hit something like a tree or whatever, and it pushes some fluid up in the tree. And it never stops. It never fucking stops. All of the heat is always moving. And the heat is just momentum. And in the case of the fucking Earth, you have a perfect example of the fact that the heat goes in as little stuff and it comes back out as big stuff.
The key thing to remember about energy is that it cannot be created or destroyed.
Well, they say it, but they don't believe it. You're creating it when gravity makes something. If I place something in space, a few hundred miles away from the Earth, and then it starts falling towards the Earth, it gains momentum. Where did that momentum come from? Where's the conservation? I just created energy. I just created motion in the universe. Now you explain to me where the fuck it came from. And then tell me how it's conservative. Where's the energy that made that move? Where's the source?
Only converted, aka the conservation of energy. Okay, but a car that's moving has kinetic energy.
And in the classical mechanics space, conservation of energy holds. It's only...
Oh, I mean, just amazing. There's no conservation of whatever this energy, this kinetic energy shit. It's never conserved every time you change the size of the object, the mass of the object. So anytime you transfer energy from different sized objects, you lose tons and tons of kinetic energy. Absolute fact. And, play this game. It's just such bullshit.
When you get to really weird scenarios.
Whatever that even means.
Stock your lab.
So this is the 3rd group of commercials.
Explore our diverse portfolio of products from trusted brands. Quickly and confidently place and monitor orders. Source your research. View technical documentation, articles, and
where you take into account the curvature of space-time where it does not hold up.
Yeah, so let's just do that again. This curvature of space-time. What the fuck are you talking about? How does the space-time do it? Because it's creating real motion. The real motion creates real heat in the Earth. The real heat has to go somewhere. So why don't you just recognize that it's heat that pushed you into the Earth in the first place?
Energy.
And in the classical mechanics space, conservation of energy holds. It's only when you...
So we know whatever that classical word he just used is. The classical space has mv squared in it. You think Leibniz is classical. No, Newton is classical, and there is no kinetic energy. And so yes, there's a perfect conservation, and the third law proves the point. The third law says the rocket can't ever collect any kinetic energy ever. It can only collect momentum.
You get to really weird scenarios where
whatever that implies. What's the weird scenario?
You take into account the curvature of space-time.
Yeah, so how do I take it into account? I'm just going to put an object in space and it's going to start moving towards the Earth. It's going to gain momentum and it's real energy because when it hits the Earth, we're obviously going to see a huge impact. So it's no doubt that it actually acquired energy. There's no doubt the impact created heat. Where did that heat go? How is that heat not new energy in the universe? Explain to me how the heat created by the impact is not new energy in the universe.
Where it does not hold up.
Stops, assuming the car doesn't smash into a wall, where does that energy go? When you apply the brakes, there's friction between the brakes and...
Right, so this is another just implied statement that somehow we calculated how much kinetic energy there was and then we measured how much kinetic energy there was in the brakes. They never measured any of this. They never measure it. They just claim, oh yeah, we only got, like in the case of the ballistic pendulum, 99.94% of the kinetic energy is lost. They claim it's heat somewhere, but they'll never put a thermometer in the device and prove it.
The wheels causing the car to slow down and creating heat as a byproduct. That heat is then dissipated into the surrounding air, and that makes the molecules in the air move faster. Things that move have kinetic energy. So
again, more bullshit. Things that move have kinetic energy. No, they have momentum. Because you'll never collect the kinetic energy. Again, what's the point of telling me there's this magical kinetic energy when it is never collectible? Ever. Ever. There's no example where you can collect it. I'm in space, okay? I got 3 baseballs. Let's say I have 3 hands. I throw 1 baseball, I go 1V. I throw 2 baseballs at the same time, I go 2V. I throw all 3 baseballs, I go 3V. So I went 3 times my velocity and only put in 3 units of energy. So exactly where does the kinetic energy play any part in this at all? It doesn't play any part. It isn't conserved. It isn't part of rational physics. It doesn't exist. It's absolutely a fable. It's nonsense. It's a Red Riding Hood story right in the core of their science. This is science. Yes. It's absolute garbage, and it's proven by that simple scenario. There's no way they can deny I didn't do 9 times the work. I didn't supply 9 times the energy, so how the fuck am I going 3 times faster?
Ultimately, the kinetic energy is transferred from the car to the air. With this knowledge, we can define that temperature is just the average kinetic energy.
Okay, so this is just, again, more bullshit. They're not going to ever do any of these experiments and actually measure any of it. So it's just a lie to say it happened or it exists. They're just making it up. There's no evidence that anything called kinetic energy was conserved. No evidence. 0.
Of atoms in a system. You see, all atoms, not just molecules in the air, wiggle like this. The faster they move.
So we know the truth is the atom isn't wiggling because the atom is just electrons and protons in, arrangements with each other. I would argue in static arrangements with each other. And the electrons and protons wiggle. But the atom itself can't really wiggle because the atom isn't really an atom. I mean, it's first the cells, you could argue. It's made out of these constituent parts that are obeying rules. The atom isn't obeying any rules. The electrons and protons are obeying the rules.
Move, the hotter things get.
Really? That's awesome.
I don't get it. There was something funny there? Huh, more things move the... I don't get it.
Temperature is just the average kinetic energy of atoms in a system. You see, all atoms, not just molecules in the air, wiggle, like this. The faster they move, the hotter things get.
So that was a picture of somebody that's hot? I don't...
Really? That's awesome.
Temperature.
It is? Oh, yeah, no, I can't get the joke. I keep trying to get it, but I don't get the joke.
All that talk about hot stuff, I think it's time we talk about the...
Oh, weird. So I'm supposed to recognize who that was in that millisecond that I saw that picture. Oh, God. I hate this planet.
Thermodynamics.
Here we
It tells
go.
us that jumping in lava is probably a bad idea, but more importantly, the absolute mess that is entropy.
So there is no entropy problem for the universe, okay, because it's a heat engine and the heat just keeps cycling, okay? So the simple scenario is a piece of matter screws up the heat cycle, right? There's heat in the universe, pressure, little bits moving. You put a piece of matter in there and it slows some of the little bits down, pushing the matter. And that differential now means that over here there's an imbalance because this energy going the speed of light didn't get where it would have been because it's pushing matter. So the Sisyphuses are supposed to get somewhere at 4 o'clock, but if they got to push a boulder, they can only get there, at 4:30. So they're going to show up too late. And that's the differential we fall into. And that's the cycle. That's the heat cycle. So matter automatically, okay, just by its existence, forces the circulation.
Literally, it tells you how much disorder there is in a system.
So it's not about disorder, it's about dispersing. So it's about the fact that you're spreading something into a volume. Obviously, if you spread something into a volume, you can arrange it in all kinds of different ways. So that's all that's saying. So it's not about disorder, it's about spreading. It's about scatter.
I also think of it as the measure of randomness.
So no, there's no randomness, so that's just more bullshit. It really isn't. It's just spread out. And the fact that we can't keep track of the precise reasons why everything moves to whatever location it moves to is just because there's too much space. We can't perceive it. But it's not because it isn't going in very regimented, rule-based directions.
A neat deck of cards organized by suit would be low entropy, and if someone...
Why the fuck would I play Minecraft? I mean, I could argue that, okay, I did for like 34 seconds and said, who the fuck would want to do this? This is such an insane waste of my goddamn time. I mean, compared to something like Tomb Raider, Minecraft, are you kidding me? Oh, fuck you in the ass. I just don't even know how people eat that shit. It's like cotton candy. I mean, people eat it, but I don't know how you eat it. Yeah.
Wanted you to play 52 card pickup.
The high-quality industrial products you need. Granger, for the ones who get it done.
In head-to-head studies with big-name longevity molecules, C15 actually delivered more cellular benefits. How many?
That has a lot of entropy.
The number of possible states a system could be in.
It has a lot of entropy. I don't know what he was saying. But anyway, the states it can be and all this horseshit doesn't make it has nothing to do with the subject. You're just talking about taking energy from things that are big and putting it in more and more tinier fragmented pieces. So you go from having one object to having a million objects.
For example, get an ice cube. No, not
states, arrangements.
That one? Yeah, that's perfect.
Space arrangement, whatever that means.
And put it in the sun. The sun will obliterate the ice cube and turn it into water.
And it'll do it, but at a very precise thing. It will never reach any higher temperature. It'll just be at that melting temperature till all the ice is gone, and then the water can get warmer. But it'll stay 32 degrees until all the ice is melted.
Looking at the structure of ice and water, we can see that ice is more neatly organized than water, which just kind of goes all over the place. Also, the water could look like this.
So it's just talking again about things that are in structures that are rigid and big versus structures that are small and spread out.
This, or even this, but the ice will always look a little something like this. In total, the system when
I can put the water in a glass, okay, and it'll actually be taking up less space than the ice would. So that's the trick of water. So part of what he's saying doesn't even make any sense because the water will actually be smaller in its liquid form.
From low entropy to high entropy, meaning more.
I mean, you probably shouldn't use frozen ice as ice water, because it is the rare example of something getting bigger, taking up more space as it gets colder. Everything else gets smaller as it gets colder.
More disorder and more possible microstates. This trend applies to everything. The whole.
So again, there's not a whole bunch of disorder in the glass of water. How can there be more disorder? Especially if you argue that if I slow it down to just almost the freezing point, the water probably isn't moving very much. So there's not nearly all that much disorder. Disorder.
The universe is on an unstoppable path to higher entropy. It's also the reason why time seems to only go forwards.
Yeah, and that's how you get to eventually the heat.
So again, there's no heat death, there's no entropy problem, because all of these things in space, every planet, every sun is radiating a ton of heat. All right, that they don't account for. So they have no explanation for where it comes from or where it's going. All right, well, I'm going to take a little break. So I'll put this back here, and you can watch it again.
Are to the air. With this knowledge, we can define that temperature is just the average kinetic energy of atoms in a system. You see, all atoms, not just molecules in the air, wiggle like this. The faster they move, the hotter things get.
Really? That's awesome.
Temperature. All that talk about hot stuff, I think it's time we talk about thermodynamics. It tells us that jumping in lava is probably a bad idea, but more importantly, the absolute mess that is entropy. Literally, it tells you how much disorder there is in a system. You
can also think of it as the measure of randomness. Like a neat deck of cards organized by suit would be low entropy, and if someone wanted you to play 52 card pickup, that has a lot of entropy.
The number of possible states a system could be in. For example, get an ice cube. No, not
states, arrangements.
That one. Yeah, that's perfect. And put it in the sun. The sun will obliterate the ice cube and turn it into water. Looking at the structure of ice and water, we can see that ice is more neatly organized than water, which just kind of goes all over the place. Also, the water could look like this, or even this, but the ice will always look a little something like this. In total, the system went from low entropy to high entropy, meaning more disorder and more possible microstates. This trend applies to everything. The whole universe is on an unstoppable path to higher entropy. It's also the reason why time seems to only go forwards.
Yeah, and that's how you get to eventually the heat death of the universe.
The entropy tells us that some forms of energy are more useful for doing work than others. Burn some gasoline and your car will move, spitting out heat and gas. That heat and gas is pretty much gasoline, just in the form of higher entropy. And as you can imagine, this stuff won't really make your car move, and the gas won't spontaneously turn back into liquid gasoline, meaning the form of gasoline with lower entropy is more useful for doing work. Okay, but if you put some water in the freezer, will it not decrease in entropy? Yes, but the fridge is not an isolated system and will heat up the room more than it will cool down the water, increasing the total entropy. Want to see some magic? Whoa, what just happened?
I remember an old joke with thermodynamics was the first law, which is energy balance, says you can't win. The second law, being entropy is going to increase, means you're going to lose. And the third law, about all motion stopping at absolute zero, says you can't even break even. Thermodynamics can be depressing.
All right, so here we go.
And as you can imagine, this stuff won't really make your car move, and the gas won't meaning more disorder and more possible microstates. This trend applies to everything. The whole universe is on an unstoppable path to higher entropy.
All right, so again, the idea of the higher entropy, if we actually thought of all of this heat in the universe as being real, then you could understand that there's no entropy problem because gravity is the anti-entropy mechanism. It's the thing collecting all of that motion, right? All of that momentum is being collected and then, theoretically, eventually released, but it's producing a ton of heat because it's consuming a ton of heat. That's all we're really in, is that cycle. It's a cycle. 50 Kelvin of heat comes in, 49 Kelvin comes out right now. If I wait another 10 seconds, I can get my 50. But I have to wait for the Earth to give it back because it's stuck inside the Earth. You can understand the heat is stuck. It has to take time to get out. So the energy that would have kept me from falling into the Earth isn't going to show up until after I'm falling. I mean, it's just such a simple explanation.
It's also the reason why time seems to only go forwards.
Yeah, and that's how you get to eventually the heat death of the universe.
The entropy tells us that...
So again, there's just no evidence of it, right? You got all these balls of fire in the universe. You can measure the heat, so I mean, it's just silly to say there's no heat in the universe because we can measure it from different parts of it anyway. So in different spectrums, there's a certain amount of 2 degrees Kelvin of microwave background. So you could just start arguing that the stuff we can't see, the stuff that's not a frequency, is 48 Kelvin. Problem solved.
Some forms of energy are more useful for doing work than others. Burn some gasoline and your car will move, spitting out heat and gas. That heat and gas is pretty much gasoline, just in the form of higher entropy.
So again, it's silly to say it's the same as the gasoline because it's not. It's much simpler elements and it's a ton of heat. So it's not just chemicals anymore, it's chemicals moving.
As you can imagine, this stuff won't really make your car move, and the gas won't spontaneously turn back into liquid gasoline.
Yes, it will, though, in the sense that the Earth will convert it back into a bunch of big blobs of matter. It'll turn it into clumps again. So it gets turned into it disperses as little bits moving, and then it gets reclumped by gravity.
Meaning, the form of gasoline with lower entropy is more useful for doing work. Okay, but if you put...
So there's no idea, there's no work, there's no experiment showing it doing any work. It can't do work when you crash cars, it can't do work in a ballistic pendulum, it can't do work with a lever, it can't do work with gears, it can't do work with hydraulics, can't do work with a spacecraft. It can't do work when a woman is floating through space with a fire extinguisher. The kinetic energy can never do any work.
Some water in the freezer, will it not decrease in entropy? Yes, but the fridge is not an isolated system and will heat up the room more than it will cool down the water, increase...
I mean, they say more. Well, how do you know it's more? Theoretically, it really can't be. There's conservation, so it can't be more.
Increasing the total entropy. Want to see some magic? Whoa, what just happened?
I remember an old joke with thermodynamics was the first law, which is energy balance, says you can't win. The second law, being entropy is going to increase, means you're going to lose. And the third law, about all motion stopping at absolute zero, says you can't even break even.
Yeah, so there's no absolute zero anywhere. So again, this is just nonsense. There's nowhere did you prove the energy escapes.
Thermodynamics can be depressing. In college.
Even if it did escape, even if the universe was leaking photons, it can afford to, apparently, by your gravity theory. By my theory, it can't. Obviously, the pressure would keep going down, so gravity would get weaker and weaker, and everything would just fly apart.
There was a bit of a learning curve with the math associated with it.
Oh, whatever. It's a concept, okay? And he's just showing how a light bulb is exactly the same mechanism, just in reverse. So instead of energy coming out, gravity is energy going in. Duh.
Some electrons apparently moved through some wires and let there be light. What is going on here?
All right, so let there be heat is the way all light bulbs worked before the LED, and even LEDs get hot. So again, the argument is this really about making photons, or is this just about the fact that if you have a surface and you heat it or you move the electrons quickly on that surface, that they will be shifting, okay, the frequency. And it's about blue shifting. So you can say that infrared radiation hits and visible light comes out because you're just compressing the frequency by moving the electrons into the field of force. So I think it's a perfectly valid argument to make it doesn't make new photons. It merely vibrates a surface, and by vibrating a surface, it causes the frequencies to be increased to a point where we can see the light, so to speak.
Objects have a fancy something called a charge. It can be positive or negative, or if you have the same amount of both.
There's no explanation for what a charge is, so it's just this magical function that exists because they have destroyed all sense of what actual force would be, and the simple way that you can obviously create this inverse relationship. So obviously I have a simulation of charge, and it only requires there to be two kinds of force, two kinds of matter, electron, proton, and 3 interactions, and that works fine. It absolutely creates exactly what Maxwell described as charges.
An object is neutral. Electrons have a single negative charge. The flow of electrons is called electric current.
So they're not saying anything, and obviously has the flow going backwards for no good reason, but whatever. And we know we don't have to flow them. We know we just have to jiggle them.
To describe it, we use 3 parameters: current, voltage, and resistance.
Right, so the voltage is just the pressure. That is how you compress electrons, they're elastic, so they'll spring. And that's all you're really saying, is that you can put electrons under pressure, you can increase the capacity for them to spring out of that compression. That's the voltage. The amperage is going to just be how many of these atoms are you going to affect. So the more atoms you affect, like in magnetism, it's a key feature. You can't use high voltage to create electromagnetism. You have to use low voltage because the whole idea is to create so much amperage and very low pressure. You want as many atoms as possible to change their shape to make the magnetism, because the atoms are causing the magnetism by being deformed by the process of moving electricity. By pushing on the atoms this way, you expand the atoms this way. They're elastic.
Current is the amount of electrons passing through a wire.
Right, so it's not really the amount, it's the amount of atoms affected. So the more you're spreading the motion to all of the electrons rather than just a tiny percent of them. So a high voltage goes right through a tiny percentage of the atoms. That's why high voltages don't melt wires, is because they're not affecting as many atoms
in a given amount of time. Voltage is what pushes the electrons to move, but simply put, it's a difference in electric potential. So you can
whatever, it's a difference in pressure. Key concept in physics: pressure is weight. Okay, weight is momentum.
Imagine it as a slope that goes from high potential to low potential,
That's a good
where the flow of current goes downhill.
Oh, it's just a bullshit. It's a terrible explanation. It's a compression. You're compressing. It's the obvious fact. You're compressing, and all the electrons are obviously feel each other's motion. So that's why it moves through the wire. And the simple argument is when you expose a new piece of conductor you connect it to some other thing that already has pressure, the pressure goes from high pressure to low pressure. It doesn't go from low pressure to high pressure. So I can't make 7 volts go into 11 volts. The 11 volts will go into the 7 volts. It's just that simple.
And resistance is pretty self-explanatory. This is Coulomb's law. Wait a minute, this is just Newton's law of gravitation in disguise. This tells us that...
So, and again, I would argue it's wrong, okay? Because again, the individual charges don't multiply their effect on each other. They're just, one charge pushes the other one has an effect. So they're just creating 2 effects in the field, and the motions they create are going to be consistent with that. There's nothing to multiply.
Electric charges attract each other in a similar way masses do.
The big difference, though, is the constant. For gravity, it's about 6.6 times 10 to the minus 11th, whereas for electromagnetism, it's about 9 times 10 to the positive 9th power.
Right, and the difference is just proximity. So again, what's the point of arguing that things that are a tiny distance from each other, somehow the force is stronger? We already pointed out it's an inverse square force. So of course, the further away they're going to be, the more distance there is, the less effect there could possibly be. So if the source is the electrons and protons ultimately for both forces, you can understand that, well, gravity only can work when you have a whole bunch of these things together, because otherwise the distances would be insane. I can't affect something miles away unless I have a whole bunch of this stuff.
So, give you a sense of the magnitude difference between the two.
It's want to cuddle, while
fake, useless, pointless, pile of nothing explanation.
like charges literally couldn't think of a more disgusting thing than to be with one another. These 4 equations explain pretty much all of electromagnetism, but don't...
Right, so the equations are so much more important than actually having a concept and a source. So they have no mechanism creating the function, because they just spent no time really thinking about it, frankly. Doesn't, it's not that hard to do. You just say, look, I'm trying to create attraction and repulsion. How do I do that? And the answer was kind of simple.
Don't be scared just because they look scary. I mean, yeah, they do, but it's simpler than it's...
The math can get complicated. Like, a lot of these conceptually aren't that hard, but when you get into the math, or at least for me when I was first learning these concepts, that's where the real challenge gets in.
Well, there's some wrong statements in the frickin' thing, right? So they say there's no magnetic monopoles, and it's just retarded to say so, because obviously the electrons and protons are behaving exactly like magnetic monopoles would. If I could make magnetic monopoles, they would behave exactly like electrons and protons. So why is there some argument that there's no magnetic monopoles?
First, the first one states that if there's...
and of course, it probably didn't help. They wouldn't let you solve it numerically in order to grasp it. You'd have to do it by hand first.
When Verizon gives you a free phone on any plan, you use AI a lot.
Gemini, show me the concealer.
The long, thin tube in the middle.
But hey, it's the new Google Pixel 10 Pro, plus Google AI Pro for 6 months.
Boyfriend of the year.
What does it take to face cancer with confidence? It takes an expert team that knows your cancer down to the molecule and makes sure you understand every detail.
We are making money off
it
your
takes
sickness.
MSK.
Yes, come to us so we can make a profit.
Electric charge, there will be an electric field or this big emerging from it. Add another and you have an electrostatic field.
Okay, so that field is false. There's no such thing as it moving from one place to the other. If I test it with a negative charge, it's going one way. If I test it with a positive charge, it's going the opposite way. So obviously bullshit.
These lines tell us in which direction a charged particle would feel a force at any given point. The second one tells us the same for magnetic fields.
So he just said no magnetic monopole, blah, blah, blah. So I don't even understand why he does this. He talks over the video while the video is still talking. He doesn't even pause the video to make his point. I mean, it's just... He did that. He does that all the time. I mean, he did that in the last video. I responded to one of his videos and he did that. It's just so annoying. You can't hear what he's saying. What's the point?
And even though electric charges are cool and can be alone, magnetic poles are not.
Right.
They're very...
Right. Somehow they behave completely... No, they're exactly the same. They behave exactly like charges. There's no difference. South poles repel south poles. North poles repel north poles. North poles attract south poles. How's it any different than charge? It's absolutely nothing different.
Very lonely, and there will always be a North Pole together with a South Pole, and a
You could argue.
So that's just bullshit. They're never together. They don't have to be together. The smallest dipole is the neutron, but there's no point in saying electrons can't be separated from protons. Of course they can.
That they're so lonely that they would destroy themselves if they somehow existed by themselves.
How would they destroy themselves? Why don't electrons destroy themselves? What the hell does that even mean? Doesn't even mean anything. LOL. Well, you can fuck off, okay? Well, you're all done here, asshole. So you can just keep making sock accounts, do whatever you want to do. You're done here, so fuck off.
can never be alone. Okay, now here's where things get kinda freaky. You know how electric charges only act on other charges and magnets only affect other magnets? Well, that's only true if they're not moving. The third and fourth
Alright, so this is the baby talk, like somehow a moving charge is doing something. So an electron flying through space creates some kind of magical field. And it's just bullshit. It doesn't do anything but do exactly what we do. We are creating a field, right? The light hits me and it turns all kinds of funky colors, does things. The reflection is completely different than it would be if I let the light hit the background. I will create a different pattern. Well, the electron's creating a pattern, and yes, if it moves, then the pattern is moving. But it's not using any energy to do that. It's just ridiculous nonsense. But the electron isn't spinning anyway. It's just a silly theory, right? So he's not really going to go into atomic theory in the sense of the spinning stupid electron crap. No reason to think electrons spin around a nucleus. Just absolute bullshit nonsense.
Maxwell equations tell us that a moving magnet creates an electric field and a moving charge or electric field creates a magnetic field. One consequence of this is that current can...
So he's talking over the video. I mean, what's the point of this? You can't tell what you're saying, asshole. Oh, just so bad. You can't hear the video, are you? So, great plan.
Seemingly come out of nowhere by moving a magnet next to a conductor. The moving magnet creates an electric field which makes the electrons...
Right, so it's just duplicating the same effect. And so yes, you vibrate a wire, that creates a field that moves through space, a change in the pattern. The pattern hits the wire and duplicates what caused it. So yes, cause and effect.
The conductor go crazy. That is called induction. In other words, electric and magnetic fields are so tightly linked that they are two parts of the same bigger thing.
Right, so there's no electromagnetism, there is just charge, so it really should just be called some sort of charge field or something. It's just the field created by electrons and protons, and there's two things that are going on. There's the pattern created when the electrons vibrate, and then there's the pattern created by the protons and the electrons being visible. So if I have 4 electrons around a nucleus, obviously from this position it looks positive, from this position it looks negative, from this position it looks positive again, from this position negative again. That's the magnetism part. The magnetism part just means that you're changing what's red and blue, and the frequency part, okay, is just the electrons pushing and changing frequencies. But it's all charge. It's just electrons and protons interacting with each other based on the field pushing them about.
Let's say we have a charge. Since it doesn't move, it has a static electric field. If we accelerate the charge...
Yep. You just yeps to this crap.
There will be a magnetic field around it. That magnetic field interacts with the electric field, which again changes the magnetic field, and this is a sort of chain reaction that makes the electromagnetic field radiate outwards into space as an electromagnetic wave. Depending on the frequency, the human eye can actually...
None of this crap has anything to do with reality. There's no proof of any fields that are pushing this stuff around in space. You know, some pushing sideways thing or something for billions of light years through space. There's some force that's pushing the thing sideways and pushing it up and down. I mean, it's a pile of shit. Made up bullshit. It's such a bad answer. I just don't know, again, why people fall for this shit.
Yes, it's called light, but most of the spectrum is invisible to the human.
And most of the spectrum isn't this wavy crap. It's just dot, dot, dot. I mean, I could draw dots on the screen. Do you want me? I mean, come on. You could just say dot, dot, dot. There, that's blue light. Dot, dot, dot. Oh, that's red light. I mean, not complicated. The frequency is the wavelength is the distance between the bits in space as it's traveling.
Yeah, eyes are radiation detectors.
Known for building special bonds. No one wants to be known for cancer.
Our skin is a radiation detector, so again, we can feel warmth, and so it's kind of silly to say, oh, it's a radiation detector. Our whole body is getting bombarded with radiation, and it reacts to it. These commercials are obscene. This is like number sixth group of commercials.
But a treatment can be. Keytruda is known to treat cancer.
Yeah,
FDA approved for 18 types of cancer, including certain early stage and advanced cancers. One of those cancers is a kind of uterine cancer called advanced endometrial carcinoma.
Fuck you.
But they have a very small band.
And is used for things such as Bluetooth, wireless charging, and confusing human apes into thinking magic is real. Hey, can we go back to the water and look at those molecules?
No, I mean, why you just sloughed over a whole big subject, but whatever.
Yeah, those. What are they made of? The molecules are made of atoms. Atoms are made of a core and some electrons.
Right, a core, and so his core has neutrons and electrons, protons, but it's really just electrons and protons. Twice as many protons as electrons. Makes perfectly good sense, and then the rest of the electrons are on the outside. So you end up with a pragmatic or practical equality between the number of electrons and the number of protons. Not an explicit equality, but a close to equality.
Core is made of protons and neutrons, both of which are made of quarks.
So that's just bullshit. So you've never seen a picture of a quark. They never showed you the evidence of a quark. It's a conclusion they drew about what caused something. So they saw something in the ocean, let's say. They saw a water spout. And they're just making up a story and telling you it's a 5-fin troglodyte when it could be porpoise.
Yep. They're strange yet charming from up top down to the bottom.
I don't know how people... How is that a good joke? I just don't get it. Speed up the video by 2x. Look, Gilbert, you can just fuck off. You're not making any kind of rational sense here. Fuck, he was my favorite. Why? Blah, 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 blah. I don't need any of this shit. So you can time out too. Uninteresting. Stay on the fucking subject of the videos or just go somewhere else, please, you fucking jackasses.
Wow. That was brilliant.
Oh yeah, there's some more stuff. Like, for example, the overweight brothers of the electron. All this together makes up the standard model, which we believe to be the smallest things in the universe.
Right, so it's just their belief, okay? Then they haven't proven it. They haven't given you a real documentation of, oh, this is why we believe it. No, nothing. None of you saw a Higgs boson. None of you saw any of this shit. They haven't really shown you anything to prove any of this crap.
At least that's the excuse we have for not knowing what quarks are made of.
Alright, whatever quarks are made out of. I mean, again, this is like LIGO saying we can measure the diameter of a proton or something, and you can't do that. You're never going to know. Even if there were such things, you could never know what they're made out of because it's so infinitesimally minute a substance. It's just ridiculous. What are you going to catch it in? What kind of strainer are you going to use to filter them out? And what are you going to make it out of? I mean, there's just that simple rule. There's things too small to make a ruler to measure.
Fun fact, depending on the number of protons...
They're fundamental in that you can't chop them up smaller, and while they can decay, they don't decay into anything smaller. Well...
I don't know what that means. They don't decay into anything smaller. They fall apart. Decay is about falling apart. So, like, if you took hydrogen 2, you could understand that I could break it into hydrogen 1s. And the hydrogen 1s are very unstable, so they fall apart. You know, those kind of arguments can be made. And the only place neutrons can actually be called neutron is when they're inside of a nucleus, because as soon as they're outside the nucleus, they fall apart. And falling apart means they separate, because they're in too noisy an environment. So if I have two magnets stuck to each other, and then I put them in a very jiggly table, I can knock the two magnets apart. So if I vibrate them enough, I can create enough noise in that magnetic field that the two magnets will fly apart.
Unless you look at string theory.
Different elements.
Oh, fuck that.
Depending on the number of neutrons in the core, you get different isotopes.
Okay, so again, the neutron is just an electron and a proton. You're just saying, okay, these are what we're going to add. And ideally, we're going to add a proton, electron, and a proton. And that will be what you're adding to transition from one atom to another atom is the combination.
Isotopes of the same element, most of which are a little overweight and very unstable, so they fall apart into...
Yes, and that's essentially part of the reason why they decay, is it's...
I don't know what you're playing with my screen name for, but obviously you're not going to last too long doing that either. Jesus Christ. Identity theft is an ugly thing. Don't play with it, fucker. So it just is, you know, pure evidence that the whole audience is shit. There's nobody on YouTube but morons.
It's a geometry problem, in addition to balances between electromagnetism and the strong nuclear force.
Right, so there's no need for the strong nuclear force. So they already know that these deuterons can be created, proton, electron, proton. That's a real concept. So where do you need a strong force? You stick an electron between two protons, they're going to get very close to each other. I put a north pole magnet between two south pole magnets, I can get the two south poles really close to each other. There's no such thing as a strong force. Silly nonsense. And obviously when I get those two south poles really close to each other, if I knock that electron out, bink, then I have two south poles that are incredibly close to each other, and of course they're going to accelerate very quickly. And that's the nature of radioactive decay creating energy. The breaking of atoms creating energy is that there's a springiness, the elasticness inside the atom is what's going to get released. The springs are going to be expanded.
But geometry determines at what angle they interact, so...
The industrial grade
another fucking commercial.
Products you need. Granger, for the ones who get it done.
Staying connected matters.
Hey, Mama.
Disgusting.
You remember
This
when you
guy
taught
is
me how to
such a
fish?
Money whore.
There you go.
Atoms. That releases ionizing radiation. Not so fun fact, that stuff kill you. If you have a...
if you get a sufficiently high dose. A lot of people bring that up, but so can thermal radiation, so can ultraviolet radiation.
Okay, so he said thermal radiation. It really can't. It's not ionizing. So it is a complete category difference. You really need to eject electrons, okay, to be really in trouble. You need to break these atoms, create ions. So if you don't do that with just plain old infrared radiation, it's not going to hurt you. Okay, but the fact is that every single bit of anything ultraviolet and above, every single one of them has the potential to fuck you up. And it's just a fact. So he shouldn't have said that. All radiation isn't alike. The higher the frequency, the more capacity to fuck up our genetics.
Radiation, so can heat. It's interesting.
So he said it again, so can heat. It really can't. It doesn't work. It ain't going to happen. It's not going to destroy your tissue.
That now we're bringing into the things that can harm.
I mean, I'm just saying by volume, of course, if you're talking about 10,000 degrees, yeah, that will be too much heat. But I'm just saying it takes an extreme amount of infrared radiation to do damage. It takes a tiny amount of ultraviolet radiation to do damage.
Harm you range when stuff like gravity, basic F equals ma stuff can harm you.
Group of atoms you can predict.
What the fuck did he just say? Basic F equals ma stuff. What does that even mean?
high dose. A lot of people bring that up, but so can thermal radiation, so can ultraviolet radiation, so can heat. It's interesting that now we're bringing into the things that...
So we know that neutrons are critical, that they carry so much energy that one neutron is like 5,000 ultraviolet photons. You know, it's so dangerous.
That can harm you range, when stuff like gravity, basic F equals ma stuff can harm you.
So again, there's no real evidence that it can. So I don't know why he's saying it can when there's no evidence that gravity causes you any harm. It's a very low temperature radiation you're getting bombarded with. So fuck that. That's silly.
Of atoms, you can predict when half of those will have fallen apart. That's the half-life.
Right, so uranium has a half-life of like 10,000 years, and yet they think it's heating the Earth. The Earth has been hot for a very long time, but don't have to mention that, very long time. How could the uranium do it?
Depending on how unstable an isotope...
And the reason for that is radiation is all about probability. We can't predict when an individual atom will decay, but using the law of large numbers, because atoms are very tiny.
I know, but that's the same thing as predicting, because you're saying that, okay, I can change it from 10 in 1,000 to 999 in 1,000. So I can make it so certain that it will decay in the next minute. So I can change the half-life of uranium by just piling it together. So the more I pile in a smaller and smaller density, the fact is it starts exploding all over the place. It starts decaying. So I am, in a sense, controlling individual atoms. It's silly to say I'm not controlling individual atoms.
We can predict when approximately half of them are going to be gone. Most of nuclear physics is really about probability and statistics.
Well, those are just, yes, and again, but it's not because it's probabilistic, it's because we can't see it, okay? So that's it. It's just that we can't see it. We know that the dice come up a certain number. It's not probabilistic in the sense that there's nothing outside of physics that's going to decide how the dice land. And it's just that we can't do the calculation. We can't figure out how exactly hard the impact was and how much it turned it and how much it twisted it. So yeah, we can't do it. Doesn't mean it doesn't have real physics. That's the disgusting part. Their silly quantum mechanics is pretending that somehow their universe has special extra forces in it somewhere that cause randomness or something. There is no such thing. It's just such bad science.
Will survive a certain amount of time. Some don't want to live, some really don't want to live, but some...
Yeah, a lot of things are so unstable, fraction of a second.
Live far longer than you probably will. Oh yeah, did I mention that light is like the fastest thing in the universe?
Okay, so we know that all of the forces are the fastest thing in the universe. So again, it's just silly to argue. Gravity's also the same speed. All of it's moving, all the force bits are moving the same speed. Why should there even be a conversation about it? It's ridiculous. Let's see. So here, you're not on the subject. Fuck you, fella. So you people really can't stay on the subject, can you? I mean, just a total waste. And he types the same shit I already told him to fuck off. So I guess I'll just say fuck off for good, Bob. These people are just such pieces of crap.
Exact 299,792,458 meters per second in vacuum. That is pretty fast, said everyone. Also, light is a wave, said everyone.
Oh, says everyone, right. There's just no reason to believe it. No reason to think there's anything waving or anything, whatever that is. This spreading thing, it's not a wave. It's not water. There's no medium. It's a ridiculous explanation.
Why? If you shoot it through two teeny tiny slits.
So we know this doesn't happen. So again, the whole two-slit lie. It's about surfaces. The two-slit experiment in photons is the four-surface experiment. If you leave the teeny tiny slits open, okay, then you get a really nice complex pattern, and it'll demonstrate that the only geometry that gets you the right answer is measuring from the surfaces. Obviously, whatever the effect is, it's being caused by the surfaces, because that's the location you measure from. Why would you measure from a place other than the source of the disturbance? Obviously, the surfaces are the source of the disturbance. I mean, this is not difficult to figure out. Teeny tiny slits. It actually says that. Teeny tiny slits. Ugh, pathetic.
It creates a fancy pattern due to interference.
And again, he says stuff you can't tell what he's just said.
Which is
so again, two patterns visible there. And what's the answer to the two patterns? Why is there an envelope pattern? Why is this always an odd number in the middle? These are all things you can perfectly understand by just recognizing that the two outside surfaces are making the little dots, and the smallest distance between two surfaces are making this envelope pattern. The geometry is so simple and obvious. If you just draw it and then draw your geometric lines, where you're saying is there's a wavelength of difference, you can see it. And then you can realize that, well, if I'm breaking photons and then I threw them all on the same linear path, there'd be a 50-50 chance I was putting them back in phase. So if what I was doing was breaking the phase, it's clear that if I throw all the pieces at the wall, there's a 50-50 chance that they're going to be in phase and out of phase. So of course I'm going to create on and off.
Just a wave thing. You see, when two waves cross, they can add up.
So that doesn't happen. And then in the radar experiment where you shoot the two beams this way, so instead of shooting them this way where they cross, you're shooting them from opposite sides, and you just move the antenna, and you get exactly the same pattern. So the two waves never can hit each other. So how could they be interfering if they never fucking interacted? I mean, there's so many ways to prove this is absolute shit. And they just, and everybody just buys it. And then you explain to them, look, can't you figure this out? Isn't that a suspicious fact? That the same antennas, okay, two radio antennas, they produce the same signal, okay, out of phase, and that you'll be able to just move the antenna and they'll go back in phase, out of phase, in phase, out of phase, in phase, out of phase. And the two signals never interact. So how could they be interfering with each other? They're either in phase or out of phase. There's no interference. It's either jamming the signal or no jamming. Jamming, no jamming. That's all there is. I mean, it's pathetic that people are so gullible and stupid and dupish. You're all just such fucking dupes. You fall for this crap and then think you're showing how smart humanity is by falling for absolute crap explanations. First they fooled you with religion, and now they're fooling you with religion science. Ugh. Whatever that means. Of course he will just ban me like he bans everyone else. I'm just saying, you're not making a physics argument, for fuck's sake. You're just talking crap. So explain to me, link me to it taking 25 times the fuel to go 5 times as fast. Link me to some explanation where rocket ships do conserve kinetic energy. Do something, or just fuck off. So if you won't just fuck off and you're just going to do this, I will random, I will talk shit. Quit posting and do it. And again, why is my name in your name? Fuck you. I'm just not putting up with that kind of crap. So yeah, it's just fuck off. I mean, this is just such horseshit from you morons. You don't have rights to my name, you fuck.
Or cancel each other out. These gaps are the spots where they cancel each other out.
No, so there's no canceling. So again, this whole idea, I canceled the energy. No, you didn't.
So in this case, light behaves like a wave.
It doesn't. So in this case, it's a big lie, a big falsehood. the actual facts, if they actually presented the actual facts, they'd see it's obviously caused by the surfaces. The single impediment creates the same pattern as the single opening. Obviously, it's about the two surfaces, each surface on each side, surface. It's about the surfaces. I can't believe I'm explaining this to these morons and they're rejecting it. Why? Why are you rejecting such a logical explanation? It works, it explains, it's perfect. The math perfectly describes it already. If you just do their math and draw it on a piece of paper, draw the math on a piece of paper, draw two slits and then start drawing your vector lines, you'll very soon figure out that, oh yeah, it's the big distance that's creating the little nodes, and it's the small distance that creates the envelope. Duh! Ugh, I hate this planet. So annoying.
Ah, screw that. Everything you know is wrong, said Albert Einstein, probably smoking crack after hearing about the photoelectric effect and discovering that light comes in tiny packets called photons. I sure hope that doesn't...
Well, anyway, that was Einstein's idea that it comes in tiny packets. And right, it depends on how you read his one-paragraph paper, but it could be read that he was actually saying that a photon is made out of quanta, energy quanta. He called it light quanta, but, you know. So it could be that it's not some object. A photon isn't an object, it's just a frequency. It's just a dot. It's a quanta of energy at a frequency. And obviously if I compress a frequency, that is, if I throw 3 baseballs really quickly, I can tip something over with the baseballs. If I throw them slowly, with time in between, then the elastic thing I'm hitting will adjust. So we already know atoms are elastic, so if I hit them with a high frequency, I can break them. I hit them with a low frequency, I can't. Duh. And that's true of any elastic object. I can defeat the elastic principle by just hitting it, pushing all the energy in the same, in a narrower unit of time. The shorter the amount of time makes something vulnerable to being broken. I mean, it's a really simple concept to understand, tipping point. You can only add energy when it's moving in the same direction you're pushing from. And the sooner I hit something before it slows down, the faster it's going to go.
Travel a whole new area of physics. Anyway, he said, as he continued to casually drop an absolute bomb on the entire field of physics with his theory of relativity. He assumed the speed of light is constant because it arises from 2 other constants. He also assumed the laws of physics are the...
I mean, that's just so bad. The whole, speed of light was in doubt somehow. Somehow we didn't know that there was a fastest speed in the universe, and we somehow thought something else was going to go faster. So again, based on the Sisyphus model, the idea that the Sisyphuses, the forces, have all of the motion, and they just give it to matter. Well, obviously they can't push the matter faster than they can go. So if they have a maximum speed, if the Sisyphus has a maximum speed, the matter's never going faster. Oh, this is just so bad, this relativity shit.
Oh, that's the best explanation ever. It's constant because it comes from constants, obviously.
For everyone, regardless if moving or at rest. Now think about it. If 2 people turn on a flashlight, but one person is standing still while the other person is on a moving train, wouldn't the person standing still...
So again, this is just so ignorant, because you're not exchanging something that can go another speed. The idea is that the Sisyphus pushing you is making the light, and what you're going to do is release the Sisyphus. Well, he can just go the speed of light, so no matter where the flashlight is where it's going to go the speed of light from. So whatever the location is, it's going to be the speed of light from that location. It can never acquire extra motion because you're just releasing something that can only go one speed. It's like letting a hummingbird out of a cage. It can be spinning around in the cage or something, flying its speed, and I can open the cage, and even if I'm moving the cage, I can't make the hummingbird go faster The hummingbird is moving inside the cage, and it can only leave going the exact speed it's going, and that's it. Can't go some other speed. So, I mean, it's so simple to understand that doesn't happen. You can't push photons. You can't make a photon go faster. Ugh, people are just so stupid.
See the other person's light as going faster than the speed of light? The reality is no.
How fast is this train going? A lot of these is like, I don't know, is that train going at relativistic speeds?
I don't know. What did he just say? How fast is a train going? Relativistic speeds. That doesn't say anything. It's not a baseball. A photon isn't a baseball. A photon isn't a clump of matter. You can't make photons leave at a higher speed. They can only go one speed. Again, the hummingbird, releasing a bird from a cage is good enough. The bird's just flying in a circle. I move the cage, it's still flying in a circle. It doesn't hit the bars. It just does this. It moves with the cage, and it spins. So the faster I move the cage, the slower its orbit. But it never touches the cage, and it just spins inside the cage, and it's always going 50 miles an hour. And then when I open the cage, it can fly out at 50 miles an hour, but that's it. It can only go 50 miles an hour. Can't leave at some new speed.
Be the same as their own flashlight. That's impossible, except if time passes slower for that person from the perspective of this person. In other words, if the speed of light is...
So we know none of this means anything, because you have to go 98% the speed of light for any of this to have any effect. So why is it even a conversation? It's just such a pile of crap.
constant, time must be relative. Also, gravity is not actually a force, sorry Newton, but rather a consequence of masses bending space-time.
For all practical purposes.
So what's the point? So you bent the space-time, you gave mass real velocity. So the masses have real velocity, move into the Earth, they crash into it, they radiate heat into the universe. What happens to that heat? I mean, it's just stupid.
As though gravity is a force. But I guess if you're looking for some extreme scenarios involving satellites or black holes that require some relativistic corrections, then...
This message
Oh, another fucking commercial. Amazing.
is brought to you by Apple Card. Each Apple product, like the iPhone, is thoughtfully designed by skilled...
Fucking asshole.
Sure.
Thought the universe is a mesh of space and time, and anything with a mass bends this fabric. Also, all objects move freely on a straight line when moving through space. Gravitation is simply the result of objects following these bent lines which appear straight to them. If you have a hard time understanding this,
So again, it's just bullshit. There's no such thing. There's no curved path for any object. It always has to be hit by a vector of force. So everything's at least in space. There's no real curved motion, because any motion that is curved has to be caused by new vectors of force being added.
you can imagine two people on Earth walking in parallel straight lines. Now imagine one standing on the east coast and one on the west coast of the US.
Okay.
If they both walk north, eventually they'll meet at the North Pole. Because of the curvature of the Earth, they
sure.
ended up at the same point even though they both walked straight.
So what? Again, it doesn't have anything to do with the creating bent space, and clearly the real argument is it's real motion in the universe. What caused it? What did it take the motion from? You can't have cash unless you got it from somewhere. So that's the argument. Conservation of energy means it's like there's a certain amount of money in the universe, and you can't get any unless you took it from somewhere else. That's the simple argument, and they're just destroying that simple argument.
Relative to themselves. Oh yeah, by the way, energy and mass are kind of the same thing, he added, which explains why atom bombs are so freaking powerful. According to this formula, even just tiny atoms can release a humongous amount of energy.
So we know the formula doesn't dictate that. The mass itself has no energy. You need to compress it with the force. The pressure is the force. The force causes the pressure. And it's that pressure, especially that pressure of an electron between two protons, and you kick that electron out and the protons go flying out. Now if one of the other protons has another electron on its other side, then obviously it's going to be ejecting a neutron. And that's the key thing. How many neutrons at what speed can you eject? And that'll decide how much of a chain reaction you can cause. So 1 neutron goes in, 3 neutrons come out. That's the chain reaction.
By giving up just a fraction of their mass during fission.
Yeah, and what's interesting is you're talking about the small one. It was pretty inefficient. A lot of it didn't even go off as far as cause fissions before the thing tore itself apart. And after all, it was a bomb. Really, you're actually not... And here, you're not even looking at the full MC squared. You're looking at the change in MC squared.
Well, again, the only part that matters is the fact that you're breaking little pieces off and that every atom will be involved in the chain reaction. So it just depends on the speed of the chain reaction. And it's so fast that there's no doubt that you're going to use most of the material is going to end up being hit by a neutron and create 3 neutrons that are again going to hit all the rest of the atoms and blow them all up too. So they all get blown up. And every time an atom blows up, it's sending a bunch of other little peripheral parts, electrons and photons, flying out of it.
By the way, in this particular instance, no, uranium-235 does not always fission into krypton and barium. Those are potential fission products, but it's really a range. Looks kind of like this. Nuclear engineers call this the Dolly Parton curve for highly scientific reasons. But yeah, uranium-235 splits into things between atomic mass of around 80 and 110, and the other bit around 125 and 150. Like everything else in nuclear physics, it's all a probability function.
So again, this probability crapola. Yes, so the idea is it doesn't split, it splits into isotopes, of different sizes, so they're not all the same thing. But they're going to have to be, it's not like a piece of it's not like a piece of radioactive lithium is going to pop out.
Fission, it's the same thing Oppenheimer used to make this thing go boom. You see, there's 2 main ways to gain energy from changing nuclei, fission and fusion. Fission aims to split the nucleus of an atom into 2 or more smaller nuclei, which is...
I would argue that there is no fission, so you have to use fusion. Fission, sorry. There is fission, there's no fusion. Combining things isn't going to give you more energy back than the energy it takes to push them together. So highly unlikely that you're going to put 2 hydrogens together, or 3 hydrogens, get a helium and some little extra bits left over, that they'll have any kind of more energy than the energy it took to smash them together. So again, you're never going to be able to gain any efficiency in this process. So I will predict they'll never come up with a fusion reactor. It's just not going to happen because the energy in is always going to be more than the energy out.
Most often achieved by blasting the core with neutrons.
Yeah, neutrons are how nuclear power plants work.
And it's so simple. I mean, just look at the huge difference between fusion and fission in the sense of, when you're fusing, you have to recreate the center of the sun, and when you're fissioning, all you have to do is put the shit next to each other. It'll start getting hot without you doing the damn thing. Okay, all you have to do is put the little atoms next to each other, purify it. Take all the impurities out, and it's going to get hotter and hotter and hotter and hotter. And now, yes, if you want to sit there and initiate it into an explosive, you're going to have to sit there and create those neutrons that'll initiate the chain reaction. But, you're already almost there. I mean, it's so simple by comparison to doing fusion.
The opposite, where you combine 2 smaller nuclei to get 1 bigger one.
Right, yeah, it doesn't make any sense, right? So you're compressing something, and you're going to get energy back. You're creating pressure and forcing something to be compressed, and somehow you're going to get energy from that process? Not fucking likely.
The energy,
usually isotopes of hydrogen,
something we call a mass defect, where the resulting nucleus is lighter than the starting.
So we're talking about isotope of hydrogen, just said, so which means there's going to use hydrogen that's not in its simplest form. They're going to use tritium or deuterium, and that itself is already a nucleus that you're going to end up breaking to make the lithium. So if you're going to break the tritium, well, then you'll gain some energy from that. All right, and the consequences that it reforms into helium, well, so what? that didn't necessarily take any energy because the real energy was breaking the tritium.
Nuclei.
Mass defect is the delta MC squared.
Missing mass is what was converted to energy during fusion. Fission and fusion are cool, but you gotta be...
And they both have mass defects. And as far as which one yields more energy, depends on the interaction, of course, but generally, for an individual event by a mass proportion, fusion typically releases about 3 times more energy. The problem is fusion...
Yeah, it releases 3 times more energy, but you had to put in 400 million times more energy, right? I mean, you didn't have to put any energy in to cause it to break. You had to put a ton of energy in to push it together.
Fusion power plants require so much more energy to induce the fusion.
There you go. Bravo. Thank you.
Which is why no one's made a working fusion power plant. They've all been experiments that have never produced electricity on a commercial operation scale.
They haven't produced any in any scale, so it's not even commercial. They've never paid their electric bill. It's just a fact.
Or you might just blow up the planet. That totally...
It would take a ridiculous number of nuclear weapons to destroy any planet, far beyond which that we're capable of. It would be relatively easier to just knock the Earth into the sun.
So he says so, but I'm just saying, hydrogen bombs, you just put more and more elements around your nuclear bomb that are capable of fissioning to some extent, and, you can you can make a gigantic mess.
Still ridiculously hard, but compared to making enough fission or fusion weapons.
Totally didn't almost happen before. Multiple times.
Yeah, no sarcasm. It didn't.
Now that I'm a mom, things are different. Verizon's different too. They let everyone in my family choose different plans. We get what we want and we save money.
Oh, shit.
Love that for me.
I hate this plan. So this is like literally 10...
This your bag, sir?
What gave it away?
Oh, you the Geico Gecko! I filed a claim for my car with the Geico app. Only took 2.
A premium movie. I could watch...
Remember when Einstein said...
I can watch movies on YouTube with less commercials in them than this guy's stupid physics video.
Said light is a particle, he accidentally discovered a whole new field of physics which he thought is just a giant hoax. Quantum mechanics. This stuff is crazy. Another German guy called Max Planck said, yes, Einstein, you're right. Light does come in time.
So, I mean, obviously Einstein didn't invent quantum mechanics, and he didn't have any respect for any part of it, so blah, 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 blah. And he spent the rest of his life trying to prove it nonsense. And it's just unfortunate that he didn't figure out that his own theory was spooky action. So he called other theories spooky action, and his own theory of gravity is spooky action. There's no source.
Tiny packets.
The Earth is not hot because it stored energy from meteor bombardments. And it's certainly not hot because it has an infinite supply of uranium, to keep burning.
Actually, all energy comes in tiny packets, or quanta. Want to know where an electron is inside an atom? It's here, and there, and everywhere at the same time, actually.
Another probability function.
Right, and it doesn't have anything to do with reality. They never measure where an electron is, so that's all this is just bullshit. And so all you're really saying is I would argue, is that, yes, everything's jiggling, because everything's in this noisy universe where there's not a perfect amount of the same thing hitting you all the time. There's an imperfect amount, so you're jiggling. Everything's jiggling in space. And and so that's what electrons are doing, but they're charges, and they're specific in specific locations. They're not spinning around, they're not orbiting, they're not doing figure eights, they're not doing any of that crap. When there's a shared electron, it's literally shared. This nucleus shares this electron, and then this nucleus shares this electron. It's literally shared in a place. Yes, it's jiggling, but it's in a place.
It's a superposition. It's not in one state, it's in multiple states at once, at least until you measure it. Then it chooses one cozy spot to be in.
They'll never show you any evidence for this. They say the 2-slit demonstrates this. It doesn't. It's demonstrating this nonsense. Electrons aren't waves. Electrons aren't like photons that travel billions of light years through space precisely, electrons move precisely by precise rules.
Schrödinger gave us an equation that gives you a probabilistic model of where you can find it if you were to measure. You can imagine this as a cloud, and the denser it is, the more likely it is for an electron to be there. But still, where exactly it will end up...
Schrödinger didn't like what they turned his equation into, so Schrödinger was on Einstein's side, pointing out how that's why Schrödinger's cat, that's why he invented that, is to make fun of quantum mechanics. The thought experiment was intended to show how ridiculous the theory is. And now they're trying to say that he somehow defended the theory, that he somehow supported the theory. No, he opposed the theory.
Up once you measure it is random. Speaking of observing particles, they're also super sensitive about their private data. Look at these two images of a flying...
So he said yes to Heisenberg. Is there any evidence? No. We can't see any of this shit, and they're just pretending that the small universe does all this wacky crap because they're allowed to make up stories about it because we can't see it. And that's it. So they make up this silly story like it's somehow, that these new rules are applied, even though they don't make any sense and you're contriving them. You're not seeing them. You're not letting the evidence prove it. You're just saying we can make experiments look like. And that's it. But it's not the truth.
Ball. In one, you can clearly see where the ball is, but not in which direction it's moving. And in the other, you can see where it's moving and approximately how fast, but not where exactly it is at the moment.
That is a great way to demonstrate that.
Oh, it's just pathetic. Demonstrate what? Your speculation about what takes place when you have no physical evidence whatsoever that it actually happens? You're just making up an invisible man story about some invisible event that takes place. There's no evidence that electrons are wacky balls. None.
Is essentially Heisenberg's uncertainty principle. You can never know both the exact position and the exact speed of a quantum particle at the same time. Okay, let's recap. A small thing can be a particle and a wave at the same time, and when we try to look at...
Alright, so whatever. Particle and wave at the same time. It's just baby talk. I mean, it's so silly. It's so still. It can be a jellyfish and a salamander at the same time. I mean, fuck this. It's just so stupid.
Them weird stuff happens, but you know what? It gets even weirder. Think back to the double slit experiment.
Yeah, right. So why don't you do the experiment and actually have an honest conversation about it? So this is the big lie about the single photon. There's no single photon experiment. They have a light source and they put dark glass slides in front of it. A dark slide is basically a little bunch of dots, a bunch of opaque pieces stuck in the way. And so there's a ton of little slit experiments, a ton of surfaces, and all you're doing is breaking photons. So the idea is you're creating a huge number of out-of-phase photons, and then that's what you're shooting into your experiment, is the material you can make a photon out of. A ton of broken photons, and then you're surprised that you're able to put some of them back together again? It's not a surprise, frankly.
Know that a light beam acts as a bunch of waves and we get interference, but here...
So again, the drawing is a lie, okay? It doesn't go through the slit and create a wave. There's 4 sources with the double slit experiment, and it's proven by just drawing the vectors. Draw the vectors from the surfaces, just like the math tells you to, and you'll see that obviously the faraway slits have lots of vector triangles you can draw where there's a wavelength of difference in the hypotenuse, and the closer the surfaces, the fewer places you can draw those wavelength of different lines. Duh. Not complicated. All about the surfaces, nothing else. The surfaces create the phenomenon.
Here's the weird thing. Even if you send individual photons after sending enough...
Okay, so that's the lie. There's no individual photon experiment.
...of them and detecting where they end up, you get interference.
And again, he's showing a pattern that has the central maxima that's twice the size, the nodes on the side. Did he explain any of that? It's nothing like water waves, so... it's just such bullshit. It's a completely different pattern than water waves create, and yet they keep saying it's waves. when it's not anything like a wave pattern. The wave pattern doesn't have a central double maxima. The wave pattern doesn't create the envelope pattern. So it's just bullshit.
Like,
good luck sending individual photons too. That's hard to measure.
Can that be?
It's hard to measure. So it doesn't. Obviously, you can't do it just because we can't control electricity enough to create any source of single photons. And I suppose the only way you could do it realistically is not to use darkened glass, but use a very weak light source. And when they do that, the experiment doesn't work. So that's the absolute truth, right? You know the photons are all going in vectors and they're spreading at the inverse square law. So you could say if I put the light source far enough away, the amount of photons that are going to go in this one path gets lower and lower and lower by probability. So you can reduce that number to almost 1 a second. And if you do the experiment that way over a large period of time with actual single photons, you won't get any pattern.
What did a single particle interfere with? Well, we think it interfered with itself because it acted as a wave and went through both.
We think it why? It's a silly explanation. And the absolute, like I said, if you actually draw the experiment and draw the picture of it, do it right, you'll see that, no, it's obvious that it's being caused by the surfaces. There's no bulging wave coming out of the slit. There's two vectors being created on each of the surfaces. That explanation works perfectly.
Both slits at the same time. That's a superposition. Okay, well, let's just measure which slit it goes through.
Try asking it, it'll tell you what position it went through.
Yeah.
That's so funny. Obviously, you can't measure where a photon is. You can't throw Volkswagens at a tennis ball. I mean, there's no way to measure the smallest thing in the world, in the universe. There's nothing small enough to throw at it. I can't see where a Volkswagen is by crashing Volkswagens into it. It's clearly not going to get where it's going.
That's not going to happen. Once you start measuring which slit the photon goes through, it stops acting like a wave and the interference pattern disappears.
So they never did that experiment. So there's absolutely zero evidence of that being anything called a truth. There's no detector experiment. There's no way to detect, and they certainly didn't turn a detector on and see 2 bars. Because it wouldn't create 2 bars. Because the damn experiment's only a millimeter wide, and it's not going to create 2 bars on the screen because the 2 patterns are going to be right on top of each other. So it never creates 2 bars. Just as you'll never see 2 headlights from a mile away, you can't see 2 headlights. You only see 1. Same thing happens here. It's impossible. The light doesn't allow you to see those 2 bars.
As every particle chooses just one of the slits to go through. Sounds kinda suspicious to me. Anyways, all this knowledge is gonna cost you 1 subscribe and a thumbs up.
So, fuck you.
This was a wonderful summation.
Okay, it's just absolute shit. So again, just completely unevidenced storytelling. And that's all fucking science has become. It's just another fucking religion. They're just telling us the story of Job or some other wacky, silly, nutty story. And that's all it is. It's not fucking science. It's a fucking religion. Ugh. Shit. Alright, so that was unpleasant. Yeah, let's see if there's anything in this useless chat of crap. Alright, so let's see. All these comments are so disgusting. Well, they're just not on the subject, and yeah, so it's really stupid. It's crazy how we have 150 billion plus neutrons. We have more than that. And we still believe that there's some stupid plan that we can't react with. I don't even know what that means, but whatever. Do you think quantum computer? No, of course I don't think. I mean, I said right from the beginning, the whole idea of a qubit is retarded. You know, you have to understand, their idea of a qubit is like tunneling. Like somehow they can get to the other side without having to go through the nucleus. That somehow they can get to the answer without going through the process of doing the equation. So somehow they can add 2 plus 7 plus 19, and somehow they can just jump over the process of doing the math and just get to the answer. I mean, it's ridiculous. Thanks for fighting for the truth. No evidence of quantum computers. Yes, there's evidence of them, but like I said, they're noisemakers. The only thing they can do is make random numbers, and random numbers are chaos numbers. So they're really good at creating noise, and that's it. And they somehow think that's going to be valuable to their physics. So they'll never make a quantum computer that'll be an AI or something. It's not going to do anything useful. But they think they can use them in science because they can plug their moronic fake number formulas in, and they'll get their fake formula number out. You know. All right. We've never seen one. Just they've been working on it for now, 10 years, 15 years, and they're not even, they're not getting anywhere. They say we may see them in decades at most. Whatever. I mean, I'm just saying, they say a lot of shit. A qubit is a retarded concept. There's no such thing. Okay. Maybe with the ghost plan. No physical evidence of any of this stuff. Can you interact with kinetic energy? This is the argument, right? I mean, even if a spacecraft hits a little particle coming at it, okay, so let's say a little piece of dust is going 1,000,000 miles an hour, whatever, and hits the spacecraft, it can't convert its kinetic energy into an impact with the ship. So no matter how I create the scenario, the kinetic energy will never affect anything. So I could shoot a bullet at this side of the ship, with 2,000 joules of energy, and I could have a recoiling gun or a soda bottle hit the other side with 2 joules. And the spaceship's not going to change because none of the kinetic energy can move the ship. It can only convert the momentum. You can only knock pins down with momentum. You can't knock pins down with kinetic energy. There's just zero evidence that kinetic energy moves more mass, more velocity. It can't do it. In every single experiment where you try to make it do it, it can't do it. So with all our technology, we can't catch a bullet and catch its kinetic energy. All we can ever catch is its momentum. So isn't that a huge giveaway that this is just a fable? And again, I've given you the clear illustration. I'm in space. I have 3 baseballs. I'm now going to do a Newtonian experiment. I'm going to eject the baseballs. I'm going to use a spring, right? Each spring releases the same exact amount of momentum. And so I release one spring, the baseball shoots out, I get 1 unit of velocity. I release 2 springs at the same time, I get 2 units of velocity. I release 3 springs at the same time, I get 3 units of velocity. Clearly, I didn't do 9 times the work. And I think you can clearly understand that those baseballs can't do 9 times the work. They can only do the same. I have momentum moving this way. The baseballs have momentum moving that way. And the fact is, we have exactly the same capacity to fuck with the universe. And yes, one moving faster can break a piece of glass or something, right? I can distribute energy in smaller chunks and cause things to fracture. It doesn't mean I used more energy. It just means that I applied the energy in a shorter period of time that the structure couldn't react to. It couldn't elastically absorb it, so the spring broke. I can hit a spring with energy that's fast enough that it just breaks the steel. You can do that. It doesn't mean that you have more energy. It just means you delivered it over a quicker, smaller amount of time. All right. No physical evidence. Okay. All right. Do you have a recommendation of a documentary that's based off of the history of physics? No, they all lie. So what's the point? They don't tell you the truth about de Chardollet. There's no documentary that says, oh yes, and by the way, I mean, I had to read this in different books. By the way, de Chardollet was sued by her tutor for stealing his Leibniz theory. So he was a Leibnizian, and he sued her for plagiarizing his instruction. I mean, it's just so funny. So, I mean, obviously she had a bias. She was raised with a bias, and she was ignorant. And there's still other speculation where Voltaire indicates that she gave up on kinetic energy before she died, that she became a full Newtonian, and that's why she was so aggressive about finishing her translation of Newton. But anyway, I don't want people to listen to me. I'm just saying, don't you understand arguments? Do you understand the difference between science and religion? They're just dogmatically telling you what a truth is. They tell you there's quarks. Like I said, what evidence do they show you? They tell you there's positrons. What evidence do they show you? Do they show you anything to indicate that any of this crap is real? No. And again, simple experiments like the double slit. They keep talking about waves going through openings. And again, all you have to do is draw it. Draw the fucking experiment, you assholes. You know, I mean, I could do it right now. Just draw it, all right? And you'll see the obvious. There's no other way to do it. There's no other way to create the pattern than to understand how it's being created, okay? So here's the pattern. If you really do a double slit and you don't fuck around, you know, with infinitesimally small openings, okay, this is what you're going to get basically, okay? And there's rules about what this pattern will look like, all right? And it's like these missing spaces aren't actually completely dark, all right? But they are darker, okay? So that's why they're there. They're obvious. They're so obvious you can see them. So it's not like they're a mystery. This is always an odd number here, okay? And what it represents basically is if I took two of these sixes and I overlap them, you could understand, oh, this one's overlapped. That's how I create that. So it's always an odd number. I drew it above. And it's just two nodes overlapping each other. And why are they overlapping? Well, because you're really creating two separate patterns. So here's the slits, and here's the openings, right? Okay. And so just draw the vectors. That's all you have to do is just draw it, and you'll see the obvious. And what's going to be obvious is that this is a gigantic distance, has a ton of wavelengths in it, right? So if you just measure the number of wavelengths, you could figure that, yes, that represents a distance, and it's only when there's a full wavelength of difference in the two lines. So if I was to make two lines, one line would be this long, and one line would be this long, right? That's pretty easy to see, right? And it's the difference. How many times is there a wavelength of difference? Well, there's exactly how many times there's how many wavelengths I can fit inside the distance. So it's really easy to figure out that this is always decided by if this distance is less than a whole number, like it's 14.5 wavelengths, then I know this is an off. No doubt about it, this is off. And then I know the rest of the pattern is just going to be created, you know, on an arc. And there's a fixed number. So the easy thing to do, you just draw your damn vector lines, right? Or you draw your vectors, wavelength of difference, wavelength of difference, wavelength of difference, wavelength of difference here at this dead spot, okay, wavelength of difference, right? So we know that the big distance is creating the little nodes, and then if you just do this simple argument, you'll see that, oh yeah, this way and this way, oh, wavelength of difference is this whole thing, okay, wavelength of difference is this whole thing, wavelength of difference. So we know the envelope's being created by the shortest distance, and the little dots are being created by the largest distance. By just drawing your vectors, it'll prove it to you. Okay, there won't be any doubt about the issue. This big distance is creating the little dots, the little distance is creating the big area. So it's saying this is half, this is getting hit by the small distance is putting light here. That's 1/2 the light. And then this other source gives it another half. And that's what you're seeing. The bright spots are the two halves add up. And so it's double bright. And this, and all these spaces, are where only one source made a contribution. So right here, only one source made a contribution. Right? And right here, only one source made a contribution, the little dot. And so you can almost see them, right? So the pattern really isn't that perfect, and you can actually see the shadows of the other little ones in here. So where there's only a half, so like where only two surfaces make a contribution, it looks dark. Where where all four surfaces make a contribution, that's where the brights are. And that simple explanation solves the whole damn thing. So all this bullshit about interference is just that. It's bullshit. And it's sad that everybody falls for it. I mean, the story is so silly. Like I said, even the idea that photons go through an opening and then create a bulgy wave that flies out like there's a medium, like photons are gigantic. I mean, you have an opening that, 50 or 100 or 1,000 photons can fit through, and you're going to say that somehow they bulge into a wave? I mean, it's just so ridiculous. All right. People are just so so gullible. All right. Let's see. Whatever. This is so easy compared to all that dumb ghost monads shit. Monoid. Whatever that is. Yeah, I don't know what that is. Anyway. All right. So. Let me go look at the statistics and see if it's worth hanging around. Long video. I mean, it seemed long to me. Yeah, I'm tired of it already. 8 concurrent video viewers. Not too good. But, what are you going to do? I can only do my part here. My part is to make arguments about physics, and their part is to try to change the subject. And that sucks. Just does. Yeah, it does in fact suck. So there are, like I said, there's so many other subjects I kind of wanted to get to. I could do some comments on my channel, but I don't really want to do them today. But they're all so dumb. So I'll just do the bomb thing real quick, just because it is interesting to understand that how dispersing energy makes such a difference, in terms of how we personally interact. So again, it's the difference between me getting hit by light bulb photons over my whole surface, or me getting hit by a laser beam in one location. You can know that the obvious fact is the laser beam will do damage, but if I spread the laser beam over my whole surface, it won't do any damage. So it's just such a simple argument that it's not about the absolute amount of energy, it's about how you deliver it. It's about how it hits the surface that matters, not how much there is. So it's about in what kind of time, unit of time, it's the faster the heat. You put heat onto a piece of glass. If I warm the glass slowly, no problem. I heat the glass quickly, it cracks. So it's just this obvious thing that it's not about the amount of heat, it's about how I, there's a word for that, dissipate it or whatever. So obviously, like I said, with gunpowder, the problem is that if I light gunpowder and it's loose, each individual piece will do all this exploding stuff, and it'll just shoot the gunpowder out, and so most of it won't even burn, and you're not going to be very effective in creating a release of energy. So you have to compact it into some kind of rolled, compacted object that will force it not to fly away. So when it starts to create pressure, it'll create a whole bunch of gas and other kind of stuff, and it'll create a bunch of pressure, but the gunpowder won't fly away, so it'll all get reacted. So the whole reason why it's in a compressed form is just to keep it from flying away before it reacts. So you want all the chemical to be converted. You don't want it to fly apart before it's been converted. And so then you can also take it and put it inside of some, pipe bomb or something, some kind of even more confining, and then you can build up even more pressure, okay, because you're forcing all of the reactants to stay inside and all of the reactant gases, so you're increasing the amount of pressure before it's capable of releasing. And the key point is when it does release, instead of it releasing where it has all these rays flying out in all these directions, it's going to take one piece, okay, and one piece of that thing is going to consume all the energy of all these rays. So all these rays, all their energy will end up being propelling one single piece. So one piece will end up flying out with all the energy that would have been all of this energy. So all of this energy ends up in that one piece. And that's what makes the damn thing so dangerous, is now you've taken it and basically made a laser beam. If you just left the cardboard and let it explode, well, then the energy is going to go in all kinds of directions. But because you forced it to blow chunks off, now the energy is going to be in single directions. And it's not going to be dispersed. It's not going to be spread. It's going to be in one place like a laser beam. So it's really just the same thing as me illustrating a laser beam versus light, and just pointing out that all you're really doing is saying, I'm going to make all of it go one way. And that's when it becomes really dangerous to us. But it's not more energy. If I just let the heat hit me, it would be the same amount of energy. It's just going to be dispersed. And all you're really saying is, I'm going to make all the heat go in one little location and move that one little object. So I think that's an important thing to understand. That's a big part of physics, is keeping energy in one direction versus the energy being dispersed, spread. And so I point that out with the faster you shoot something through something, the less it has contact with the surfaces, and the less energy goes in these other directions. So the faster you can make something go, the more durable it is in terms of keeping its direction, because there's technically less friction, less contact, less dispersion, less spreading. Really important. Sucks I am still in the hospital waiting for my kidney surgery. Well, I feel bad. Yeah, that's no good. Hospitals suck. I don't believe I'll ever go to one again. You know, I went to one as a kid, and I don't think I'll ever go back. Just because I couldn't stand the environment. No, as bad as it was being sick and had my appendix out and it got infected, and so I was there for 10 days or 12 days or whatever the fuck it was. And so it was kind of grueling. It was listening to the other people in the other rooms screaming and shit. It was so fucking creepy. Oh, it's just, it almost makes you want to puke just thinking about it. It's just so bad. Oh, God. I mean, hospitals could just make you sick, just going to one. But I'm like that with a lot of stuff. Christmas lights make me want to throw up. I don't know exactly what that's about, but it's just like a reaction. It's like, oh, it's like they you know, it's just like I have this visceral, horrible reaction to my brain just incorporates it into some kind of, you know, sickening event, and I just can't, you know. It's just really weird, you know. Yeah. So, I mean, it just obviously has something to do with my atheism, and, you know, maybe I had some bad experiences on Christmas and something, and so my brain has this negative association. You know, Christmas lights are a threat. It's like you get sick on some kind of food and you never eat it for the rest of your life. It's just, you know, same kind of reaction. Yeah, human brains are such a pain in the ass. I mean, it seems like, okay, this should be fixable. I should be able to just convince my brain, don't react, don't be an asshole, don't be fucktarded. And I just can't do it. I can't stop it from being fucktarded. It just keeps doing things that just really are irritating. Physiological things. It's like I still got vertigo. I've been really working at trying to get rid of it, but I mean, I just, I start climbing a ladder, and once I get past 10 feet or so, all of a sudden I'm in trouble. And it's crazy, because as a kid I was, I loved I'd climb 100-foot trees and just blow in the wind. I used to love that kind of shit. And, can't do any of it now. Yeah, it's so subtle though, because in some cases you can't find the one event. In some cases you can, but in some cases you just can't find the event that, how the hell did that trigger this? So the only thing I can think is that there was one time where I almost fell off a roof when I was doing roofing. And, it spooked me a bit, just because, hey, you got to be careful, Gary. It's like these cases where, you don't, you don't wear safety glasses, and then you're cutting a piece of wood and a piece of wood flies into your eye, and you say, gee, I'm lucky I can still see, and you say, gee, I ought to be more careful. And so it's just that kind of a thing where I just basically said, I got to be more careful. So I didn't react crazy to the circumstance, but I can't imagine what else caused the problem. I mean, I can't think of any other reason. I enjoyed sitting on a roof, and I liked having the view, and I liked all of it. So I don't know what else it could have been except that one time where I almost fell backwards off the roof. Yeah, you call it imprinting, I call it conditioning, but yeah. I guess neither word really suits the point we're making, that one single fucking bad experience can just ruin it forever. Remember when we went to the Grand Canyon, we were right outside that big tourist attraction hotel, and they have this big metal guardrail, where you can stand out and look over the Grand Canyon, and it's like this 300-foot, 400-foot drop. And I actually got up and walked on that rail, because I loved walking on fences. And, I was about 10, 11 maybe. And I it was great. It was great fun. It was a nice challenge. Do I have the guts? And so like I said, I can't even explain how I didn't. Heights never bothered me. And it's just so funny to be exactly. I can't even look at a picture of the Grand Canyon now. Yeah, it is just funny. Brains are just so, and you're just saying it. There just should be some way I can regain my confidence, and I haven't been able to make it happen. I mean, maybe you got to take like nitrous oxide or something up on the roof with you, and so you can have a nice, happy, fun time or something, and that'll fix it. I just don't know how to fix it. Alright, so running out of steam here. And such. So maybe I'll go. Let's see, is there anything else I could really deal with? I don't think there's anything I need to. Yeah, so we'll get back to day videos next time probably. It's just unfortunate these people will not engage in the conversation. I mean, I politely emailed this guy and he just, no response. He just won't engage. He's got his own little shtick he's doing, I guess, and he just, he doesn't need to bother dealing with subjects he's not confident. And it's not even that he's confident, right? Because he doesn't say anything. He doesn't really do anything. He just says, yeah. I mean, there's no arguments, really. I mean, a tiny percentage will say something like, oh, it does create other isotopes besides just barium and blah, blah, blah. Sometimes it creates some other elements, but that tiny little disagreements. Yeah, it is irritating. Alright, so anyway, thanks for the contribution from the people that tried to make one, and fuck you to the rest, and such. Oh, God. Humans, I just really don't like people at all. Yeah, it makes all of this so much more difficult than it should be. But anyway. I mean, just your belligerent resistance to the truth is just a matter of record. So I'm just saying it's a matter of record. They write this story in the future. This will be a big part of the story, is that, well, yeah, I spent 10 years making good arguments, and all I got back was crap, dogma, statements about how I'm too stupid. Nothing on the fucking subject. Nothing demonstrating what needs to be demonstrated, which is there any evidence at all, any place on this planet demonstrating it taking 25 times the fuel to go or spin something 5 times as fast? Is that a sensible statement about reality? Does it in fact take more than a proportional amount of momentum to make a velocity? Was Newton wrong? It takes more than 2 times the force to make twice the velocity. It takes more than 3 times the force to make 3 times the velocity. Is there any proof Newton was wrong? And I won't get any of that. Yeah, so that's the problem. No feedback that's reasonable or on the subjects. I can highlight the ballistic pendulum over and over again. Do you really think we don't have the technology, the capacity to make a ballistic pendulum that can actually collect some of the kinetic energy, just some of it, without losing 99.94% of it? And all it has to do is collect 99.5% for you to make free momentum. So that's the catch. And that's the joke. You can't collect the kinetic energy unless you believe in free momentum. And that is just... I don't know how you go there. I don't know how you can imagine the universe working that way, where you can make free momentum. I can put 30 pounds in and I can get 90 pounds out. No, I can't. Alright. So, enough and such. So, till the next time, and such, and so forth, and whatnot. So we will hit the button and say goodnight and such.